Yeah, oh yes, yes. So, hello everyone. Today we will be doing Sharky Devil. Okay, it's okay. Wait, how many of you people know about or have like done a bit about this conflict? Like the basics, at least. Like not really the basics. It's pretty easy. But how many of you have seen this before?
I have.
I think I recall it, but I'm not sure about the name. It's like the BIC, like the AI, whatever.
Yeah, yeah. It's AI. It's ABC Cup B AI ABC Cup.
Okay, yeah, that's it. Then I remember. I don't
Yeah.
remember the names that.
Yes. So, well, obviously, like go slow, start one by one, and all that stuff. So yeah, let's just. Oh, also, this is like a huge config, so it may take time. So see, I'll only be naming points if they are necessary, unless the diagram will be too cluttered. Additionally, there will be a lot of definitions, so you can potentially forget points. So yeah, just tell me if you forget points. I is the incenter.
We'll be definitely like just specifically doing Sharky Devil, right?
Yeah, because like Sharky Devil is Sharky Devil is like the coolest config, but it's also like the largest config in my opinion. Like in terms of coolness, I think only mixed linear or maybe curvilinear come close. But like Sharky Devil is like by far the coolest thing ever. So yeah, uh, what do I want? So I is obviously the incenter. We define the arc midpoint, the minor arc midpoint of BC to be. Oh wait, did I mess up the spelling? Yeah, to be like MA. Okay, the midpoint of BC is M. And oh, also people switch on your cameras. I don't want to like stare at blank screens. Like Arham and Ronit, very good. And then we have like line. So this, which is the other arc midpoint, will be named NA. I don't know why they call it N. Probably just because of the M, but yeah. Wait, what do I want? Yes. So now let's just introduce the main guy here, like the only important guy right here. Uh, this legendary point is the Sharky Devil. We oh also like in general, this is like not a Sharky Devil advice, but like a general thing in geometry. Always, whenever you have a problem, which has certain points, look how you can construct the point itself. Oh, also people, what is this? Okay, like don't chat. I won't be able to check chat. So just feel free to speak. And if you're not able to speak, I'll check chat eventually and you'll get the answer there. Yeah. So like look how you can construct the point. Not only is it helpful if you're bashing the problem, but in general it gives good intuition of where the points should lie. Yeah, I'll hide the unnecessary lines because well they are unnecessary. Yeah. Uh, what do I want? Okay, so now see people, the first thing that you have to prove that this point D, or as I'll rename it to A dash, is the antipode of A. Oh, also, is everyone clear about the definition of how we define S?
Yes.
Yeah,
Be
great.
straightforward, right? Like,
Yeah, it's very straightforward. It's nothing complex. So, like the first thing, it's not that difficult. Prove that S, I, and the A antipode have to be collinear. I'll just make some adjustments till then. Hmm. Also, whenever anyone has like a proof of the thing, just tell me because it's like a large config. Yeah,
Yeah. Okay. I'll go ahead.
yeah, just go on. Like, and let's see, don't take permission. I'll just like feel free to speak whenever you get the
Wait,
chance.
you've named the A vertex S. Okay, fine.
Wait, why did I name the A vertices? I'm pretty sure I'm not that dumb. Yeah, I did not name it S.
Oh,
Okay, just
it came on top of it.
yeah,
Ah,
fine,
yeah,
fine.
it came on top of it. I know I'm not that dumb to name it S.
Okay, so like AI is the diameter of the AFE whatever circle.
Yeah, true, true.
So angle ISA is 90,
Yeah, exactly.
and extending it back onto the circle, you get A dash must also be the diameter because it's
Yeah, true.
that's it.
Exactly, exactly. So like everyone gets it right. Uh,
Right, like F and E are roots of the tangents from A, like get 90s.
yes, yes, precisely. Like so, just the entire point of the thing is that like this thing here is 90. Therefore, whenever like you take the intersection, it must like intersect at the point where it goes there. So yeah, pretty straightforward stuff. So the next thing is prove that SD, which is the touch point, in touch point of BC, and MA are collinear. Okay, wait, before this, here is everyone here like comfortable with SPICEM?
I'm not.
Okay, so I'll just like give a very quick thing on SPICEM. So where is the pen? Yes. So look at this. Whenever you have that, you have like one circle and you have like this triangle here, and then you have a smaller circle which passes through this vertex. Okay. Okay. Well, I'll just show you here. It's easier, I guess. Look at this. So observe how you see here. What is this? Yes. Yeah. So you have first ABC and then you have another circle which intersects S, right? Like you have another circle which passes through S and intersects the original circle at S. So
Right.
like by this spiral similarity thing, what you get is that triangle, uh, yep, triangle SFB will be similar to triangle SEC.
Okay.
Yeah, and additionally, triangle SFE will be similar to triangle SBC.
All right.
Yeah, so that's all that spiral similarity says. So everyone here is able to see that S is the SPICEM center that takes. Okay, SPICEM center just means the center of spiral similarity that takes EF to BC.
All right. Yeah.
Yeah, so everyone here sees that S is the SPICEM center that takes EF to BC, right?
Yes, yeah.
Yeah,
I
Yeah,
think
this
I've
is by
actually
angle
used this
theory.
in a problem before.
yeah, it's very useful. So like just prove that S, D, M, A are collinear and then we'll move on. Also, whenever like we solve a problem, I will make this the line that we have proven exists. I will make that line dotted. So eventually where we like I go, okay, technically this circle also should be dotted because we know it exists.
What are we going to prove now again?
We are going to prove that S, D, M, A are collinear.
Okay.
Yeah,
I think I have it.
yeah, go on.
I mean, it's a bit off because I'm taking inversion on triangle on a circumcircle of BIC.
Circumcircle of AIC,
No, BIC, BIC.
BIC. Ah, very interesting. Yes.
So
Okay, go
we want to
on.
show that D maps to S. Then of course you have collinearity.
Yes.
So one thing you can see that we define S as the how we define S is from the intersection of the circumcircle with uh, like circle E from the diagram. That's how we define the Sharky. Like
Wait.
the circle over there is called E.
Yeah. So we have this circle and like Yeah, so you're just defining S, right? It's like the big circle cap the small circle,
Right. So if we find out the
right?
intersection of those two circles when they are inverted,
Yeah,
other than A, we're done.
yeah, correct.
So I guess everyone knows that ABC, circumcircle of ABC goes to BC.
True. Go on, go and speak.
That's
Yeah. And what happens to this?
right. So that one, since we know that I stays fixed,
True.
we know that since A is on the circumcircle of ABC, it must be on line BC, A dash must be on line BC.
Indeed.
And it, of course, since AIMA are collinear, it must be on the
Yeah.
angle bisector.
Indeed.
So that intersection over there must be
Yes, precisely. This has to be
A. And since we know that AI is the diameter of our circle, if you want to, of our dotted circle.
A. Yeah, yeah, yeah.
So IA dash must be the diameter of this circle.
Correct.
And since we know that D is the foot of the perpendicular from I to BC, IDM is 90, and
Yes.
so D lies on on that circle as well as on BC.
Great. Yeah, that works. Yes. So, did everyone understand the proof? Also, the other people, Ornab, Shrimoy, and okay, I won't spell that. I won't be able to spell that. Whatever. Kumar Roy. Kumar Roy. Yes. So, are people clear with this? Like, did you get the proof?
Yeah, I did.
Great. And others?
Is there like a proof besides this, or like is this the proof?
There is, I believe, a proof besides this that involves spiral similarity and ratio chase. So, like, I also had this proof in mind because it's the cleanest. But yeah, we could always try to find a spiral sim solution. So, like, wait, so like, okay, wait, are people not comfortable with inversion?
I'm not comfortable with spiral sim, but inversion's fine.
Yeah. And Arham,
Yeah, same. I am fine with inversion.
great. Then I guess this proof is done then. So yeah, I'll make this thing dotted. That's good. We need more dot stuff.
Just a question on the spiral sim. I will try it out later.
Yeah.
But to show that 3 points are collinear, you'll probably be taking the angles made at D.
Yes.
So, so is that going to
Oh,
be the center of
not
spiral
actually.
sim?
Not actually. Like it will be like S will be center of spiral sim, and then you like project the ratio ABMAC. I believe you'll project this cross ratio onto the line BC and then ratio change it out. It's
Yeah,
Ah,
projective. Okay.
yes,
Then
you'll like, project it and then like use the stuff there. Yeah. Either way. So this is your next property. This thing, this point which I've marked. Prove that this is the foot of the altitude from. Okay, wait, am I messing something up? Yeah, I'm messing. Wait. Yes. See, SI cap EF prove that it's the foot of the altitude from D to EF.
Mandar, I'll just write it in the chat. I think to you, I think me and Nishant have done this before, so I'll just write it to you in chat.
Yeah. This like take 2-3 minutes. Wait, also, are you able to see what I'm searching right now? Like what is visible?
GeoGebra.
Then that's good. That's good. Yeah. Yeah, exactly. Ronit, that works. That is the solution I intend as well. Okay, people, do you want to spy some proof of that as well? The collinearity. Do you want to spy some proof of that? Like, if you want, I'll just okay. Either way, I'll just write it down. So, yeah.
Yeah, I'm fine with it.
Others like just feel like go on with the DP proof that DP is perpendicular to EF. I'll just write that proof down. So you observe that BS by CS is equal to BF by CE, which is BD by CD. Yeah, so you like look at the spiral similarity in triangles SFB and SEC. What you get is this relation that BS by SC is equal to BF by CE, which is equal to BD by CD. Now, BD, the last step is just length of tangents from a common point. So this implies that SB by SC is equal to BD by. Why is this happening? I don't like this. What? Yeah. SB by SC is equal to BD by CD. Hence, D lies on the angle bisector due to angle bisector theorem. So SD is the angle bisector, hence it passes through M. Cool.
Now we have to prove that D is on the like DP and EF are perpendicular, right?
Yeah. Like the proof you send me works, and that is the proof I have in mind.
Right. Okay.
Yeah. So, people, what are the ideas you are having? Like any ideas, any thoughts? Like
Me and Ronald have the same thing, so I won't comment, right?
Right.
yeah, that thing.
What is P again?
What?
P.
P. P is SI cap EF. Uh, SI intersection EF. Does that make sense?
I'm just curious, what is the circle DEF with respect to the circle AF? Is it like the okay, yeah, it's the incenter excenter circle, yeah.
It's just the encircle, right?
No, AEF. AEF with respect to AEF.
Oh, okay. Yeah.
With respect to AEF, the circle AEF is the circumcircle, but how about the incircle of ABC? What do you
Wait, Mandar, your voice is breaking.
Circle BIC. Am I audible?
Yeah.
Yes.
Yeah.
Yeah. Am I audible now? I think there was some another internet issue. It's just a bad room.
Yes,
Yeah.
though you are frozen couple of times.
That's sad. That's sad. Hopefully it won't happen again. Yeah. So I was saying that the incircle of ABC with respect to the incircle of the circumcircle of AEF is the BIC circle.
Yeah, that's what I was thinking. That's all.
Because like I is the arc midpoint, because
Correct.
AI is the angle bisector, so I is the arc midpoint, and then it passes through EF, so it's the BIC. Okay, so I'll just like present the proof why P is the perpendicular bisector. So like anyone who has the proof or wants to say.
By the way, is BPNA collinear?
What?
BPNA.
No,
Is it
no,
collinear?
it's also not.
It's not, right? Okay, I was just like hallucinating. We took some point G.
Hi, what is happening? What is this?
Sorry, yeah.
I
Sorry.
don't like this at this point. Yeah, it's not.
Yeah,
Colin.
it's not.
Yes,
It's not.
it's not Colin. Yes. So yeah. So the idea is that you invert about the incircle, because you have like a collinearity with this. You invert about the incircle. In this, what happens is that A goes to the midpoint of EF, right? You can obviously see that A goes to the midpoint of EF. Similarly, B goes to the midpoint of DF and C goes to the midpoint of DE. So the circumcircle becomes the 9-point circle of triangle DEF. Is that understandable? Did everyone get that?
Yes, yes.
Great.
Yeah.
Yeah. And then the circle AEF goes to the line EF, because it passes through I. It goes to the line EF. Hence, the second intersection must be the foot of altitude, because we know that the circumcircle becomes the 9-point circle, and the circle AEF becomes this line. So the two intersections will be A and S, like the line and the 9-point circle. The two intersections must be A and S. We know that the midpoint is correlated to A, hence the foot of altitude would be S. Did everyone get that?
Yes, yeah.
Yeah, great. So let's just do the next thing then. So
I have a question.
yeah,
Like, did we already prove that I is the midpoint of AMA? Wait, I don't think that's true.
I don't think that's true.
All right, that it's the
not.
Dumpty point, that is. It's the Dumpty point.
Did you
It's
prove that S
Not
goes to
bounty.
P?
what?
S goes to P?
Yeah, under the in-cycle inversion, we did show that, right?
Okay, right. Right.
Yeah. So the next thing is show that lines SNA, EF, and BC converge. In fact, like the fun part is if I should also introduce. Okay, wait. Ideally, now I can define the. I should hide these circumcircular arcs. Uh, hide. Okay, yeah, like what I'm doing, it's totally irrelevant. So just go on with the solution of yours. Like whatever you're thinking, just go on with that.
Like projectivity?
Okay, wait, like have you people studied this concept? Yeah, it's projectivity. It is projectivity. So
Oh, I
like
was just guessing. I'm not sure about how to prove
nah,
it.
just like okay, yeah, whatever your proof is, just like if you have a proof, just go on with it. It's fine.
I was actually thinking if we could introduce some more cyclics with that point.
What do you mean by cyclics?
Cyclic quadrilaterals. So like you can draw some more circles. Like assume that point which we're saying is collinear is like, I don't know, T.
Yeah, it is, I believe, named T. Usual people do name T.
Right. I looked at S, so the next thing was T. So
Yeah.
like maybe some cyclics with cyclic quadrilaterals which have a vertex with T.
Vertex with T. Wait, how would you use that?
I'm not sure. I was just guessing some stuff by looking at it.
Huh, true, but that's an interesting idea. Interesting idea. Uh, wait, have I frozen again?
No.
Okay, so it's good, good, good. Yeah. So we have this. What do I want you to prove next is the question. Yeah. We have shown this in this, so I will drop it. Okay, this Zoom thing is so annoying. It just makes like this window so annoying. Yeah. Wait, so someone, I think Nishant said perspectivity. What would you like want to take perspectivity through is the question.
So like perspectivity through like okay, NAMA.
Harmonic bundles.
Yeah, that's a good idea. Like, is there any harmonic bundle you can spot right now?
TBDT, my guess is.
TBD?
I don't know the order, but DBCT. I'm not sure.
Yeah, correct. And why would it be harmonic?
Give me a second.
Yeah. This is
Okay, because they concur, right? The Menlos Siva,
precisely.
Mohammed said it
Yes,
in chat.
Cheva Menlos, precisely. So everyone sees that this is harmonic. Then what we do next is project
And S.
with S the perspectivity we take. So B we project from the circle ABC. From the line BC to the circle ABC through S. Okay. So B remains at B obviously, and C also remains at C.
D goes to
D goes
okay,
to
yeah,
M, and then the only point that works is NA because obviousness.
You need it to be -1.
Yeah,
And
you need for it to be -1, it goes to the other Archimedes point. So hence these are pulling. Did that make sense?
Yep.
Okay. Yeah.
Yes.
Everyone.
Yeah.
Great. So I will just delete some stuff now. Like, how do we delete stuff? This is not good. What? Yeah. So the next thing I want you people to prove is the following. You take the line ID. Prove that the intersection of ST and ID lies on the circle. This point, and it's named T1 usually.
some sort of like ratio chase or something.
Wait, how would you go about ratio chase?
All angles. That's all I want to do.
Wait, but how would you ratio chase it? Like,
I'm just I was thinking like NAM is like perpendicular as well. So like we could do something with that, but it's not concrete.
true. That's true. Like honestly, ratio chases work out. I think I'm pretty sure ratio chase works
Yeah,
out.
wait. So TD I just want to check it out. Okay. So
Yeah.
TD squared is equal to TF into TE.
Yes.
Okay, which is equal to TS. Okay, define P1 as the intersection of TS and the circle.
TS and the circle. Okay.
Like phantom point, whatever.
Yeah.
So TD squared is equal to TS into TP1, I'm sure, I think.
True. That's true. Next.
Then, wait, what was I thinking? Wait, okay, so DS is perpendicular to TP1.
DS is, yeah, true. That's true.
So we're done, or are we?
Oh, just a second, Nishant. Yes, Nikhil. So there is no question. We are just going over the thing. Just a minute.
Sure. Wait, let me just check if I made a mistake. Okay, wait, we are, oh, sorry, yeah.
Yeah, I am back.
Yeah,
So,
we're done. I figured it out.
okay, yeah,
So,
go.
so
Okay.
DS is perpendicular to TP1, we know that, because S and MA are equivalent. DS is perpendicular
DS perpendicular to
TP1.
DS is perpendicular. Yeah, true. Wait, why is this true?
Because SMA and TS
Okay, right. This has to be
TSNA
90. Correct. Yes.
90, and
Yeah.
then TD squared is equal to TS into
What? Wait, did I freeze again? Okay. Does my net
No, you're
suck?
not freezing.
What?
No, you're not freezing at all.
Okay, so it was their net this time. That's good. For one time, it's not my net. Yeah. So, anyways, so anyone else was a proof. So wait, where could he have been going with this? So this has to be 90. Okay, and what else? That's about it, right? He can't, I don't know. Yeah, so any ideas, people? Rohit, Ornav, Shrimoy, Kumar Roy, and Nikhil. Any ideas?
Just thinking.
Okay, I'll
yeah,
just
sorry,
give.
the laptop ran out of charge.
Yes. So yeah, go on with your proof then.
Oh yeah, so now we know that TS into TP1 is equal to TD squared.
Yes, correct. TS into TP1 is equal to TD square. That's
So this
correct.
means that TD is the tangent to the circumcircle of DSP1.
Correct. So
So
yeah,
that means that angle P1SD is equal to PDT, P1DT, which is 90.
yeah. But how does that show that it passes through I?
Yeah, but angle, we have like TD is like P1D is
Oh,
perpendicular to TD.
right. This is 90, so the 90 has to. Oh, yeah, correct. Yeah. So did everyone get that proof?
Yeah, right.
Yeah, great. So yeah, the proof I had in mind was wait, what was my proof again? Okay, yeah, the proof I had in mind was observe that this angle is equal to this angle because like parallel lines, and then this angle is equal to this angle. Hence, the triangle SP1D is homothetic to triangle SNAMA. And we're done.
It's how do you show it passes through I?
Cool. Anyways.
Oh, wait, okay, it's homothetic. Oh, right.
Okay, wait, does internet suck again? Wait, does my internet? Okay, Nikhil, yes. So what we are doing is just the config Sharky Devil. So like we are just exploring this config. Like there are a bunch of properties which we hopefully try to prove. Does that make sense?
Your voice is breaking slightly.
Uh, okay, my internet is just bad again. I honestly don't know what to do at this point. But
Okay, it's better now, don't
yeah,
worry.
life. What?
Yeah, now what are we trying to prove?
It's got better.
Yeah, let me just like draw the next thing that we have to prove. Okay, so do you want to like prove a good thing or a bad thing? Okay, let's just prove a good thing first. So
I don't know
prove
what's good
that.
and what's bad here.
Yeah, that's true enough. Doesn't matter, doesn't matter. Don't worry about it.
Okay.
I hate this feature. Whatever this is. Why does it take my point? Why in the world is my point P1 and this same? Bro, what? Bhai,
What
that's
happened to S
okay.
actually?
Like what? Why is GeoGebra playing with me today? But it's just bad. That's just bad.
I think when you double
I think you
click on
should just
something,
like
something
download
random
GeoGebra or
happens.
something.
What?
You should just download GeoGebra so that you don't have to like depend on internet connection for it.
That is true, but okay, yeah, that is good advice. Okay, so wait, are you people familiar with the X point?
X point?
Do you people
I
know
think
the
I've
X
heard of
point?
it, but I don't remember it at all.
The QX, the QX point. Do you know that?
Q point or QX
Q
point?
point.
The Q point, there is this Q point, and then you take AQ cap BC to get the X point,
Oh,
and there
okay.
also is a Y point. Yeah, so
Oh, why?
leave that. I don't think that. Okay, so like yeah, yeah. So the point here, okay, wait, no pun intended, but the idea is that y is the dx point of triangle DEF. Y is the dx point of the triangle DEF. Yeah, that's correct. So
What is okay?
essentially,
What
if
is the
you
X
draw the
definition?
triangle DEF out, okay, the x definition is let Q be the point on circumcircle. Let Q be AH cap ABC. Then
AH cap
X
BC,
is
fine.
AQ cap BC.
AQ, okay, fine. Yeah.
AQ cap BC.
Yes, fine.
Basically,
Yeah.
auto-center
So
version
in
of Sharky
simpler
Devil.
terms, yeah, exactly. That's a very good definition. So essentially, what will happen is that you join QD. That's the idea here. So I think people are not familiar with that. So we should just go past it. Okay.
Right, so which is the X point of DX point? I didn't understand.
Y. Y is the DX DEF. Okay, that's the coolest. The DX point of triangle DEF. Essentially, you
Okay,
take.
I see. I got it. Yeah.
Okay, you got it. That's
No,
great.
wait, I still need to know. Sorry.
What?
I still need to know what you were talking about.
Okay. I want to. Okay, essentially, you take Y and D. You take DY cap the circle. Okay, you get this
Yep.
point.
Correct.
Yes, yes.
Then the next thing that we do is take the orthocenter of triangle DF. Okay, wait. I'll just
Okay,
draw it
fine,
now.
fine.
Like not.
Triangle center.
Do you have
Okay,
to?
I get it. Yeah, right.
I don't have to, but I'll just do it. G is the
Oh, so
orthocenter of
that
triangle
point,
DEF.
so like DEF cap DY is going to be the Q point.
Yeah. So you would get essentially that H. Okay, this like what the hell? Why is H? Rename
I think you can
H to
just in
Q.
circle invert and hope for the best.
Don't. It's like angle cheese.
Okay,
Angle
I
and
can do
cross.
that also.
It's just angle and cross ratio cheese. Okay, Ronan, do you get it now? Like
Yeah, yeah.
HSD or yeah, exactly.
Very good.
So yeah, it's very good. I like we'll eventually reach more fun stuff where we introduce like the Semidian and everything. That would be like way crazy.
Wait,
But
we already have the Semidian, right? AMA. Okay, Semidian or something else, maybe.
AMA is the angle bisector. It's not the
All
Semidian.
right, shit, right. AD.
AD is not the Semidian. It's the it's nothing honestly. It's not named.
Like the
Like Semidian, I'll recall like Semidian is like you refer reflect the midpoint. You reflect the median about angle bisector to get the median.
Right. I remember. I was
Yeah,
just
AD is the
guessing.
median of triangle DEF, right? The D median.
Yeah. Yes.
Wait, what's the median of DEF?
D median of DEF is AD.
Ah, AB.
Yeah,
No.
AD. Oh, because like see, A is tangent to EF, right? Like AE
Yeah.
and these are tangents to like the tangent config here.
AD. Yes. Oh, okay. Now it makes sense.
Yeah. And like are other people understanding what we are doing here? Ornab, Shrimoy. Okay, Ornab, I'm not butchering your name, right? Shrimoy, Nikhil, and Kumar Roy. Do you people understand what's going on? A yes, no, thumbs up, something. As a yes.
Mandar, I think
So
couple of times you're breaking, sometimes you're coming back.
what? Yeah, my net is this bad. I'm sorry. I don't know.
If you have hotspot, maybe
If
it
I
would be a
open,
I think
yeah,
next time we should
hotspot.
download GeoGebra and
Okay.
keep it ready. Instead of using some web version.
Yeah. I'll just like have it downloaded next time. Okay. What is AD midpoint of?
The midpoint
What,
of AD?
Nikhil? What do you mean? We have not introduced the midpoint of AD.
Right.
Yeah. Okay. So what was I thinking next? Okay, an easy one now. Prove that TI is tangent to AIEF. And there can be like multiple proofs of this. I'm not sure. There can be multiple
Wait,
proofs.
TI
It's an
is
easy
tangent
topic.
to what? PIC?
TI is tangent to AEF.
Okay.
Okay, and
It's
it's an easy
the
proof. So whenever you get it, just go on.
it's the common tangent of BIC. I'm giving a guess here.
Yeah.
Like we
Yeah.
already know
True.
that
That is indeed true.
BIC. We already know that BIC and that I just call it the Sharky circle for now. Like they both, we already know that they're both common tangents. And then you have like kind of
Yeah, they are.
power of point, and then you can finish it.
Yeah, that is indeed the proof. But how do you go about proving that?
By the way, is TD squared is
It's
equal
not
to
difficult.
TB into TC? Sorry.
What?
Is TD squared equal to TB into TC? Okay. Wait, what?
It's not. I don't think it is. I don't think
Okay,
it should be.
then I will
Okay,
tell
it
you.
is, I think. Yeah, it is. It is indeed true. That is indeed true.
I don't wait. No, wait,
Okay,
no, how? Wait.
there are eyes. Okay, this is not an eye, it's the line
It's a line.
thing. Okay, so GeoGebra class is the only eye. I will be point. Lines will not be named. We won't be naming lines. This eye is just a line.
Oh, wait.
Yeah.
How is TD squared equal to TB into TC?
Oh, because of TDBC is -1. So inversion about TD will take B to C and hence you get.
Okay, but isn't it true that TD squared is equal to TS into TP1, but TB into TC is equal to TS into TNA?
Oh, wait. Am I messing up? Oh, yeah, you have to define the midpoint. Okay, sorry, I messed up. Sorry,
Okay.
that's false. It's
Yeah.
it's from the midpoint. It's from the midpoint. But that is a way you can prove it that this is tangent. Also, I'll introduce the circle BIC now. BIC. Yes. It's the common tangent. So you just have to prove that TI is tangent to this thing. Wait, how would we prove this actually?
Is it the common tangent, I sure?
Yeah, it is the common tangent. I know that, but I don't remember the proof. So we'll have to prove
Same.
this.
No, wait, it isn't. It isn't. It isn't the common tangent. No, it can't.
Oh, it's not the common tangent. Damn. It's not even the tangent. Wait, why am I messing up? Wait, what
So
was
wait.
the tangent?
The tangent was with diameter AI. That's
Wait, so TD squared is the length of the tangent. Then how is TD equal to TI?
So you want Ti square is equal to Ts times.
Okay, XT is probably the tag. Okay, that makes more sense now.
Okay,
Ah,
yeah,
right.
this is why you should keep practicing config and not just be overconfident. Like, don't
It actually looks like XH is XI is parallel to TE.
where is T and where is E equal to, right? Because as it's the tangent, AI will be perpendicular to X, and then this is also perpendicular to X.
Yeah, so you can prove it by power of point this one.
Correct. So like X is on the radical axis, XS plus times XA is going to be equal to XB times X.
Yeah, right.
Oh,
So
yes,
it's
this
a,
finally works out. Exactly. This is why. Yeah, precisely. That works out. That works out.
and that's
Did everyone
why
get how
XI
we?
square.
Okay.
Yeah. That
EF is parallel to TI. I mean XI.
Yeah, that is also true. Because
But
see, as it's the tangent, AI will be perpendicular because AI is the diameter, right? So XI is perpendicular to
Okay,
AI,
okay, yeah, that's true. Right.
and then EF is perpendicular to
Oh,
AI
that's
as well.
cool.
So they are, yeah, it is indeed cool. And it's like the common tangent of BIC as well. That's also good, I believe.
right, that's
Yeah.
because you can see XS times XA is equal
Wait,
to
let me
XI square is equal to XP times XC.
Yes, precisely. That's it. Okay, what else do I have to prove? What else do I have for you? Okay, let's just do some simple stuff now. Prove that SIXD is 90.
X
Yeah,
what?
prove that. Wait, I'll just draw the circle. Circle SID. Prove that SIDX is cyclic.
Cyclic. Okay.
Indeed.
Wait, it follows, right?
Yeah, like we're done. I mean, I have a proof.
Exactly.
Yeah, it's like
Because
it's just
like
A antipode.
Go on.
Right.
Hold is
Yeah,
So
exactly. A antipode. So angle SIX is 90 and SDX is also 90. So it's like
it's I
precisely.
think
you mean
XDI.
IDX?
XDI. XDI and XSI.
Nikhil, cyclic means that they lie on the circle. Just a minute, Nishant. Nikhil,
Sure.
cyclic means that the four lie on a circle. Is that clear, Nikhil? Yeah. Yes. So yeah, exactly what you people were saying. Like ISX is 90, IDX is 90. So they're cyclic. Yay.
Yeah.
Then what else do I have for you people? Let me look up this. I don't remember the entire concept.
A lot more than what you've done the other time.
It's going to be fun.
We don't. I think no. We are making good progress. We are making good progress. We are making good progress. I would like
1
to
hour
say
over,
that.
right? Yeah, 1 hour.
What?
We
1 hour
didn't use that J point over there.
We didn't use so many points over there. What are you talking?
Okay, that Z
We have to
point
start
is like
somewhere.
it's Z point is actually the external angle bisector cap BC. It's like Apollonius circle. So the good idea is that I D this T dash will all lie on the Apollonius
Oh, okay,
circle.
okay.
We will come back to that. We'll come back to it. Don't worry.
Okay, I
Don't
worry.
didn't get
We'll
that, but fine.
come back to that.
It's Apollonius.
Yeah,
Don't
yeah.
worry. Time.
We'll reach it. We'll reach it. Trust.
Yes, no
Yeah.
problem. We'll do
This
this.
is the next circle that you're. This is the next circle that you're proving. This is also a very simple one. Just like go on. TSPD. Okay, well, we know that the incircle exists. Wait, can we show that the incircle exists?
Huh?
The heck? I thought. Why do you want to show
Okay,
that?
Why
okay.
is
Incircle exists. So yeah, we can prove it. We can prove that incircle exists. Good.
Yeah, it's not like
Yeah, like we
anything.
need to. Yeah, like, see, the hardest task would be proving that ABC exists. Like, why does a triangle exist? Why do you believe that we are on like a plane? We could very well be on a sphere and ABC just doesn't exist. So we don't know if ABC exists or not. That is why I'm not dotting it.
That's why it's an
Wait, I do.
axiom. If we just take it as an axiom for this point.
Yeah, we can take it as an axiom, true. But if the axiom is like ever turned out to be false, all this is just jargon and nothing. Sad, sad. Anyways, people prove
Okay,
this.
right. I have a proof.
Yeah, go
Yeah,
ahead.
go on.
You can go ahead.
Like we know that angle TPD is 90
Yeah, right. Same, I think. It's
Exactly.
and TSD is also 90
Yeah.
because TSD is equal to NASMA. That's
Yeah.
90.
That works. Great. So we have these are cyclic. Good. What other stuff do I have for you people? Wait, why do I have so much stuff? Do I have to introduce new points now? Have we actually exhausted everything we had? Ah, sad, sad. We
Wait,
might have to.
Mandar,
Yes, go on.
why don't you go to the diagram and we'll try to find out stuff?
What?
Like we'll try to guess stuff and try to prove it in the original diagram which we have.
This diagram.
No.
the
This
diagram we are doing. Yeah.
Yes.
Oh yeah, go on. I think like we have exhausted everything with the points we currently have, I think.
Really?
Yeah, sad,
Okay.
but true.
Okay, right. We showed parallel lines like T.
Okay, wait. I think we have one thing. We could introduce. Okay, I don't want to introduce the most goated point. Like this point, I believe is the most goated point ever.
That's why it's a G.
I have. Oh wait, that is such a good idea. Wait, I will name it G. Great. Yeah, I'll name it G. Wait, do I have G here? Wait, have I used? Okay, G. Okay, no, we can't name it G because G is taken to be this median cap. Oh wait, but it's actually like 8 point that it's named G.
Why
Yes,
it's like so
we'll name
fussy
it
about
T
what?
dash for now. What?
Okay. But that
See,
seems
Why
like a
don't you
lot of
why
headwork
don't you
for.
rename it W instead or something?
oh right, W. Okay, we'll name it W. Good intuition, people. I like this. I like this. We'll name it W. And now, yeah. So okay, this property exists that ADNA, WDNA are collinear. Just go and prove it. It's easy.
So what's the definition of W again?
The second intersection of the circle TSP with ABC, and is my
Okay.
audible. Yeah. Okay, wait. We are just losing people. I guess I'm not that clear, but yeah, whatever. Whoever doesn't understand, just tell me. I'll explain. Yeah. So prove that TSPD, we have the circle. Wait, do you want me
Okay,
to darken the circle?
orthocenter. D is the orthocenter of NAMAT.
What the hell?
I'll just do that for now. So
Yes, I'm pretty sure
D is
that's
the
kind of.
center of NAMAT. Wait, damn, that's okay. That is true. That is very true. Yeah,
Like
that's
that's
Wait,
it. And then you're
let
done.
me
and
get
that
a hold of
also I
this.
believe shows that. Yeah,
Wait, let me get a hold of this.
that's
Just
like crazy. Why would you do that? That is the most utterly crazy thing. Okay, I think that's the proof Anant presented as well, but I did not have that. That's true. That is very true. Okay, so
okay.
Nishant's proof is like crazy stuff. Observe that
Okay, let me try. Just a
MEDS
minute.
is like,
Okay, now let
yeah,
Ronit also try. Like you can give him
Yeah,
a
yeah,
try.
yeah.
that's like very good. That's a very good proof. That's very good.
Too good
And that also
intuition,
shows
Nishant.
that.
Okay. Like we anyway know that BMMA is 90. Okay,
True. That's
fine.
very true. That's very true.
Now we need to show like what? MA and NAB. MA and NAB, that's going to be an altitude. We need to show that.
You get half your cyclics from there. Like I can see, like you can get like so many circles from just that observation.
Oh, yes. Okay.
There's like
Right.
infinite stuff
Therefore,
coming out.
orthocenter. Yes, I got it.
You get like
So cool, Nishant.
tons of circles from that.
Right, and
SP.
like that's the intersection point with
Yes.
BIC. I think that's the intersection point with BIC.
Very cool. Yeah, the other way around you could see this is let W be the intersection. Then we already know that angle TPD is 90, hence intersects at N. Because like
Wait.
NA and NA are antipodes.
I have a hunch. I don't know if this is right.
Go on.
That if we take triangle BMANA.
DMANA. Yeah.
No, not D, B. BMANA.
Okay.
Yeah.
We show D is the orthocenter of that. So
Wait, we have it. We have shown it with T. It's not likely not true with B.
It's not true, D, B.
It's only true with D. Like yeah, like 4 points all lie in orthocentric system, so it can't be true with B. So it has to be true with D. Like
okay,
only D.
okay,
It's
then
Then
right.
you get
Okay,
so
I
many
had a
cyclics
hunch.
due to, oh, sorry.
No problem. I just had a random hunch.
Yeah, so you get so many cyclics because it's the orthocenter, right? Like
yeah,
D, M,
precise.
M, A, W,
Yeah,
Right,
NA,
6 cyclics you have directly.
S, D, M. Like you can get, not even 336. Yeah, that's
okay,
at
I
least
won't be
6.
making that. I'll only make one of those circles because, well, I want to have a life and not die in this Sharky Devil thing. So
You mean get lost, rather.
yeah, true. Okay, so do you like? Okay, let's do the next thing.
Wait, so what is the Q point of TMANA? I wonder.
TMANA Q point. It's okay. So for that,
We need to draw the circle.
yeah, let's
Circle.
let's just do it. It could be something good. We could be
I
on
don't
to
know. I could be like doing random stuff like.
yeah, like random stuff is usually how maths is developed. It's this very weird point here. This is the Q point.
Okay, not that useful.
Wait, what? How?
Because this is the
Yes.
Yeah,
Yes.
it is that.
so let's maybe join it with A or something and see if something good happens. Okay, nothing good happens.
No, wait. I think that's the
That's the altitude.
altitude.
What is the altitude?
The
AG.
A altitude is AG.
Oh, wait, is that true?
The A altitude, it looks
Check it, just check
perfectly
it.
true.
Maybe we could be like
Damn.
random stuff. Okay, no.
Not true.
Oh,
It's off by a little. Sad. That's sad.
I think the config took us like.
I okay, wait, people, we are not dead. We are not dead. We have
Control Z saved your life. Huh?
so what was that? Why did it have I just hate this. I just hate this. Okay, like GeoGebra is like, see, in my original diagram, no matter how much I move stuff, it doesn't do anything. It's such a well-behaved thing. Okay. So this point, okay, this G is not okay. We'll come back to G because it's not that goated right now.
Yeah, like I
we
was
have
just
a
like
different
seeing random
point.
stuff.
Yeah. Wait, what is this point? Why is this thing dark randomly? That doesn't matter. Let it be.
I think we just draw two lines. We drew EF and we drew like TE. That's why.
Oh, right. Okay, so the next thing would be that APW is concyclic. Sorry, collinear, not okay. Technically, it's also concyclic with a circle. Like a line is technically a circle.
Klein.
Yeah. We work in clients, people. We work in clients. Okay, but this is not the definition I want you to work with. Do I want you to work with this definition?
Wait, what
Yeah,
is
you can work with this
TE?
definition, honestly.
What is TE with respect to MATNA?
Okay, people, sorry. Wait a minute. We'll do some magic stuff right now. So line.
Okay.
Finally M comes into the picture. We had drawn it like ages ago, but it finally comes into the picture. And that too just to be reflected.
C median, no?
Yeah, to get the C median. Reflect line I1 about line AI.
It passes
And
through
it's showing an error. Why?
I think because
like,
AI is not a
you
line
have to
we've
choose
made.
a
Okay,
line
it's
reflection, right? I don't know.
Wait, no, we can choose anything. What's line AI?
It's reflect object comma point for some reason
We
No,
have line AI.
as the argument.
No, it works with that as well. Yeah, N. Okay. Then
So
we
close
get
to D. It's so close to D.
Yeah, I think it
very
just
close to it. Okay, okay, so like some random stuff, but I was making a problem for Lamau Revenge, and I actually like this point G, it troubles you so much. Actually, like what you get is okay. I'll show the problem that I had at the end, towards the end.
Wait,
Okay, wait.
Can I
Lamau,
know a bit more about this Lamau revenge?
it happens in like IMOTC, I think.
Yeah, Lamau is the stuff that seniors give to juniors, and Lamau Revenge is the stuff that juniors give to seniors. I was making a geo problem on Sharky Devil. That is why this horrendous thing exists. And this T dash is like the absolute goat point ever. It has like infinite properties.
Oh, Indian Elmo. Indian Elmo.
Yeah, Indian Elmo. Indian Elmo Revenge, technically speaking. Okay.
What's
No.
the full form of Lamau for this time?
It changes
Yeah,
every
yeah.
year. It changes
No,
every year.
okay, no, like Lamau and Elmo have not had a full form in ages. Both. Like
Right.
Lamau never had a thing, and Elmo always had a thing. Okay, so the way I want you people to remember this is take the Sharky Cap Simidian. Okay. Sharky Cap Simidian. This is like absolutely. I don't even know how I would show you this. This is okay. Let's not bring W in the picture right now. Why?
Fine.
Idiot. I
I could see it.
I hate GeoGebra. Like Byju's only has one thing going for them, that's GeoGebra, and then they can't make a good Okay, I won't control it this time. Yeah. Like Byju's literally only has one good thing and it can't make that nice. So that's skill issue. That's skill issue. Okay, wait. We
Oh
have
God,
to
are you gonna make the
Wait, so what do you have to
intersection?
prove now?
what?
What are we trying to prove now, by the way?
Okay. Firstly, we are trying to make the diagram. That's much more important. Okay.
Okay, thanks. I gave up drawing the diagram like 15 minutes back.
Yeah. What the hell? Line BC.
Enjoy, boy.
BC.
I think you can just write BC
Oh,
and
there,
then
M.
you can
It's
just
M.
write capital B, capital C, and it should work. I'm not
It
sure.
doesn't work. It doesn't work. It
No,
doesn't
no,
work.
M,
This
comma
people
A,
doesn't
M,
work.
comma A.
No, just try. I mean, you remember it, right?
Wait, no,
Wait.
it's M, comma A.
It's not M, comma. It can't be. Okay, wait. We'll. Okay, no problem, people. We'll just define it to be the intersection of lines. Okay, we are very good people. Line S G cap line B C. Yeah, we have J. That's good. Okay. So before that, do you want to like do an easier thing? Okay, let's just do an easier thing first.
Sure.
Prove that AI is tangent to SID. The circle SID is tangent to AI.
Same.
It's an angle chase. It's an angle chase, which
You
works out.
don't need angle chase, right?
Yeah, you likely won't need angle chase, but
You can just say similarity because AIX is 90 and
Wait,
ASI is
just
90.
a minute.
Oh, sorry.
oh damn, bro, you're like very crazy. Okay, like that was good. Okay, why?
Tangent and reverse tangent.
Let me think. Similarity, you say, huh?
No
Yeah,
need like tangent and reverse tangent.
yeah, reverse. That tangent secant. I think that was the thing's name. Power
Why
of point. Essentially, power of point. That
Wait,
was
let me think. Okay.
That's the way you look at. That's why I look at like 90 stuff like that, like the perpendicular from the 90-degree vertex.
yeah.
That's how you can look at it.
That was a very good proof.
Similarity, you say, huh?
Yes, indeed.
Or you could do reverse tangent stuff. Like,
Yeah.
up to you, sir.
Okay, wait.
I'll just go get my glasses.
Yeah.
Okay. How do we get similarity? Like. We are proving that AI is the tangent to circle XSID.
What are we proving? Just a minute. Wait, what was Ronald? Yeah, just a minute, Ronald. Nikhil. So we have to prove that the line AI is tangent to the circle. Okay, I'll darken the circle and the line for now because visibility.
It's just the circle that's selected.
Okay, yeah, I just selected the circle. I can't select both at once, sadly enough. Yeah, so we have to prove that this circle is tangent to this line. Yeah.
Okay. Okay.
Okay,
Is
you have XDI is 90 and XSI is 90.
Yes.
by the way, Mandar, if you don't mind, like, is XS equal to XJ? I'm just curious. No, it
XS
can't be.
equal
No,
to
it can't be.
XJ. It's not.
It's most likely not. Yeah.
Does it look
I
like?
mean, yeah, it's not. It's not.
Sadly, it's not. Sadly.
Wait, what about XJ and SJ?
XJ and SJ.
Okay, that has a bit more hope.
It could be. It could be. We don't know. Let's just just prove this AI thing. Then we'll do that.
Don, we are waiting for you.
Yes.
Come on. Okay, I'm just going to tell what I'm thinking. Okay.
Go ahead.
Yeah. Go on.
XDI 90, XSI 90.
True. True.
Angle SXI equal to angle SBI.
Yes.
XI is diameter.
Yes.
So XI must be perpendicular to AI. That's what we want to prove.
True.
And that we already have. Yes. Wait, what?
What?
Didn't
I
we
have
already
no idea
prove
what
that?
went from like. I just heard
Yeah,
already have, and I'm like, how do you get that?
Yeah.
No, didn't we already prove that? Okay, fine. Never mind. I'll just try again.
Okay, what do you have to prove next, Mandar? By the way, can I know at least that?
Yeah, I'll just tell that to you and everyone just listen. See, so we have introduced this median point G, right?
Yeah.
Take SG cap BC, let it be J.
Yeah.
Okay. Prove that APJ is collinear.
AP. Oh God, I don't think I can get this.
And like the crazier thing, actually APJ and W are collinear.
Okay. XI is the common tangent of ASIE and BIC. So we're done.
Yeah, precisely. That works. That
Okay,
was
what was the similarity thing again? I didn't find any similarity.
he said the same thing in like longer words. No, he didn't
Yeah.
even do that. He just said the exact same thing, nothing.
Yeah, I just said the same thing.
Yeah,
Oh,
I
he said
thought similar. Like you could use similarity to indicate power of point, and then you could
yeah, but
finish.
that's not necessary.
But you could just do it by
which
reverse
triangles are
tangent.
similar? Which triangles are similar?
Triangle
ASI and AIX. Sorry.
No,
Wait.
those are not similar. We don't know that they are similar.
They are
Wait, why do we know that they are similar?
ASI and
Oh yes, they are
AIX.
similar.
Wait, why
ASI is 90 and AIX is 90. I mean, no,
Yeah.
it's not AIX is 90, but how do you explain? I forgot.
No, we don't know that beforehand, Nishant.
Yeah, we don't know. We know that AXI and SXI are similar in some order, not in the same order, because one is 90, like one angle is 90 and this angle is common. So by similarity, we would get AI squared is AS into AX, and that
Correct.
would complete the problem.
But that's also PowerPoint. Yes. Okay.
Yeah, indeed. In fact, like I'll show you, this is you don't have to prove this right now, but actually X, S, F is like F is F, and when you draw XI cap BC, these 4 points come out to be cyclic.
Oh.
Yes, and like and by like symmetry, X, S, E, and the other point also come out to be cyclic.
Right. Can you just check if Sj is equal to Xj? Just create a circle with center in J.
Yeah, I'll do that. Just a minute. Let me delete these circles first. I want to what do we want to check?
Js is equal to Jk. Jx.
No.
No.
Sad. They are not. Okay. Yes. This is proven. This is also proven. Okay, yes, people. I'll just like I'm just very excited about this. But see, my proof. Okay, you saw this thing, right? This circle stuff here. Now,
Right.
what you do is F this, the other point, and this. This is actually tangent to this AI. Yeah, and that's
Let me
easy.
think.
That's easy to prove.
Right. Yes. Because you have parallel lines, na? Okay.
What points would be non-concyclic? Okay, like take any 4 points and they're likely non-concyclic. Like the number of 4 points which are concyclic is like very low. It's
So
still counted.
it's a simple angle chase to show that that's cyclic. You have EF
Yeah.
is parallel to BC and
Yeah,
not
exactly.
BC.
What? Okay, wait. Proving that these four are cyclic.
No. Proving that KFPI.
They're not. Like P is like not in the circle.
No,
Sorry,
P is not on the circle.
No,
No,
sorry,
KFI.
the point was AI is tangent to IFK.
Oh,
PowerPoint, I
IF.
guess. We can use PowerPoint, my guess is.
You don't have to use PowerPoint. See
Okay.
this. FI is angle F, angle IFK is 90
Oh, it's
because
90. Oh, right.
yeah,
Oh,
and
yeah.
then angle XKI is 90. So
Yeah. Oh, how did I miss this stuff?
it happens. It happens. Okay, so like my problem was, in fact, you don't need the cyclicity that I showed you, SFKX. It's not particular to S. You can take any point on the circumcircle and the cyclicity still holds. Like you drop perpendiculars from uh, X. So let S be any point on the circumcircle. AS, this you drop these perpendiculars. These 4 points will always be concyclic. It's not a special property of Sharky. And this tangency is a special property of Sharky. So my question was proof that find all points on the circle such that this circle and the other circle are tangent to AI. That's crazy. And like, see, my final problem, which is like extremely diabolical, is likely going to be to find the locus of triangle
KFI.
FIK.
Yeah.
Okay, I had a
And
power out.
oh yeah, nothing happened. Nothing happened. If a point between 2 points can't be cyclic, is that true? Yes, it's true because 3 concyclic points cannot be cyclic. Yeah. So like I'm pretty sure the as you move S around the circle, the center of this circle goes in a parabola. That's the thing. It's crazy. And
Wait, move what?
when you move the point S in the circle ABC,
Uh-huh.
the center of triangle IFK moves in a parabola.
Parabola. I thought like ellipse or something, but
Yeah, it's a parabola. And you see this other circle that we have. Wait. EI, this thing. Yeah. And by power of point, we also get that this circle exists. So
yeah.
these I'll delete these because these aren't really in the main config, but they exist. So see this.
Yeah.
Now the good idea is precisely when the and the parabola for this circle and the parabola for this circle is just the reflection about AI.
Yeah.
Now precisely when the parabolas intersect with the line AI, we get that all the three circles are equal. They coincide precisely.
Okay.
It's an interesting property. Not very useful. I don't think this will ever be useful. But yeah, it exists. It exists.
Okay. I've not seen many. Okay, I've seen a few questions of Sharky Devil, but this deep I've never seen stuff.
Sharky Devil, like I think there is one Iranian geo which like asks you to have like there was this what was that CAMO problem. There is this we'll do the CAMO problem I think after this. It had like inversion and Q points everywhere.
Fine. Yeah. So what are we doing next now?
Yeah, bye Shimon. Yes. So maybe we'll come back to this circle later. I'll do this with this because you can't prove it with direct Sharky stuff. Okay, it's not that difficult honestly, but yeah, we'll come back to this later. So
Okay.
the current problem we have is triangle ABC. G is the Simidian cap ABC. Okay.
Okay, wait, hold on. For the AI tangent to XSI, I think I made a mistake while stating my similarity. So it was the midpoint, like AI intersection EF is the midpoint, or like whatever midpoint of EF, and we know that Y midpoint and that midpoint is parallel to XI. So that's it. That's 90.
Yes, that's true. But you don't have to go through that process. We have shown that XI is tangent to the
We
circle.
already
So
showed parallel lines. That we already
Sure.
had.
Yeah, we already showed parallel lines, right? We know
yes.
it's parallel.
What?
We know it's parallel.
Yeah, true. That's true. Like you don't have to go through the extra step. That's what I'm saying.
Yeah.
Yeah. So currently, you people's proof is let G be the Simidian cap ABC. Okay. Let J be SG cap BC. prove that A, P, J are collinear. This is a good problem, honestly. This is a good problem.
Firstly, like, okay, fine.
Okay,
Right.
and another thing, other points that we have introduced till now will likely not be useful. Like this problem was actually this year's MBL Balkans happened recently, if you people know. A friend of mine was there. This problem was asked in the MBL Balkan. Like in the camp, some IMO guy gave this problem. It's not a hard problem, but it's a good problem. You should know this in the context.
Was it Om who went?
No, it was not Om. It was some IMO medalist. It was not Om.
Like, who went over there?
It's Kannad, if you know him. He
Oh,
is also yeah, Kannad. He's also a modern OMC.
Oh, Bhattacharya.
Yeah, Bhattacharya.
Okay, right. I met him.
Yeah. Wait, where did you meet him?
Bangalore. Math
Wait,
circle.
wait, does he live in Bangalore? Yeah, he does live in Bangalore. Yes. Great. Yeah, so go on,
Wait,
prove
why
this.
the number of people just decreased? Wait, there are 4
Okay,
people.
I honestly don't know why there are only 4 people left. Okay, see, so Shremoy left because she had a class. Arham, I assume, did not understand. Zayden, the person, was going to leave in 15 minutes either way. Nikhil, yeah, like this is like the amount of sad, but whatever.
Okay,
Yeah.
similarly.
So prove this, and after this, go on by proving that JW is.
Nikhil's here. Yeah, Nikhil's here. Yeah, we got
Yeah.
it.
Yay, hello, Nikhil.
Yeah, I had a blackout. Again.
Cool. Anyways, continue, people. So prove this. In fact, I have to. Okay, see, the proof Kannad gave me was a complex bash, which we won't do because
Yeah,
we
let's
are
not do that. Let's
sane
not do
people.
that.
Like we would. Okay, it's not hard to complex bash this honestly because you can just like take ABC unit circle A minus A, then A not cap that. It's not hard to complex bash this.
Wait, can we do ratio chairs on
What?
Can we ratio chairs? I was thinking.
Yeah, I was also thinking about the cross ratio chains.
Like, okay, yeah, one of those two. Like,
Because
either-
see, we would okay, so what we would want is XJBC to be -1. Right?
XJBC. Okay, hold on. Let me find X.
X.
That. Okay, XJBC.
XJBC -1 because X goes to A, so J would go to this. So if we can prove that XJBC -1, we would be done. Okay,
Wait,
this
didn't we have something about the X? X is the Q point of something.
no, Y is the DX point of DEF. We don't have any.
Oh, something else we had. I don't recall why.
Okay, and also people, with the introduction of W, we have officially gone beyond anything that Murica covers. So yeah,
Huh?
we have.
Right.
What?
Yeah, like Murica doesn't cover W and G. It doesn't.
Okay, Mudita covers all this. Okay, ADG is not collinear. I'm just rambling. Leave it.
Yeah, wait. So wait, how would we chase this ratio though? That's the big question.
Okay.
Yeah, I'm not good with projective.
Don't worry. Let's see what we can do.
So wait,
Okay,
what
is
if
SW parallel to AG? No, that doesn't look like it. Leave it. No, it's not. Then what else can we have?
wait, so this then BC D. Wait, can we look at like BC inversion here? Like circle BC. If we invert about that, what happens?
Circle BC.
Circle BC or BIC?
BC with the diameter B.
Oh, okay.
With diameter BC.
A goes to the Humpty. A goes to the Humpty.
Yes,
I know
yes.
that much. And S, what happens to S under BC?
Like,
I think
What happens? What
S
happens to
goes to-
circumcircle?
I
What
think
happens
S goes to H.
That would be very cool if it happens.
oh yeah, S does go to H. Yes, S does go to H. I remember it.
Why does it go to H?
I don't remember.
True,
I just
true,
remember
true.
it just goes. It goes to some very nice. It's either H or O. I think it goes to H, right?
Can we just check if S, H, and M are collinear?
Yeah, just a second. I will do that, but let me just draw the circle we are inverting about as well for
Right.
sanity purposes. Okay, and this
Oh,
is
wait,
such
no.
horrible
S.
triangle just being
Oh,
painted.
you meant that S. I meant like median point S. Median point and so. Okay, I was thinking of root BC inversion. Sorry, my bad.
It's fine. Don't be sorry. H. I'll rename H to be H1, and then I'll define H to be the triangle center of A, B, C. This. Okay, no way in hell does H go to it.
No,
Right.
no, no. I was talking about SH1M.
Oh, that could be true. That could be true. That could possibly be true. It's not.
No, you just
Ah,
miss. You miss
Like,
by that
like,
much.
like people like.
I think the fact that we're getting it this close is because ABC is almost looking 90.
Yeah, that's clever.
yeah. That's why H is actually quite down also. So very much close to B.
I think you should
Yeah.
like try to make it a little more acute. I mean, if you can,
Yeah,
without risking your diagram. Ah, okay.
I can. Okay, see, I won't. It only happens when I. Okay, I'll show you how. Yes. Oh, it didn't happen this time. That's it always fails me when I want it. Bad relation. Bad relation.
Okay, let's see. Look, okay. So let me prove that. Okay, okay. How do we prove it by?
Wait, so I know proofs that are not angle chase, that are not cross ratio chase, but I want a proof that's cross ratio
Yeah, I
chase.
also want something like that. Like, can we
Wait,
spend
so
some time on
basically
that?
we want J to go to X, right?
J to go to X. Yeah, under BIC we would want J to go to X. Can we show that?
Wait,
What
under
happens to
BIC.
A? What happens to
Just
BIC?
Like, how does X go to J under BIC?
X goes to J
Not
under
does.
BC, right?
BC. You meant BC, I guess.
Yeah, BC. It goes under BC. What happens to the circumcircle? It goes to
Okay, wait, let me think.
it goes to a line, right? No, it doesn't go to
Yes, it goes to
no.
line BC.
It does not go to the line BC because it does not pass through M.
Diameter, yes.
Okay, wait.
Oh.
So wait, I'll just like state some POP stuff because my brain is not working well.
Yeah,
So
yeah, just
HB
go on.
into XC is equal to XS into XA, and BJ
Correct.
into JC is equal to SJ into JG. Okay, what else do you do after that? Uh, so
Mandar, I don't understand why doesn't the circumcircle of ABC go to BC?
Wait, we are not inverting about BIC.
we're doing on the BC. BC
We
is
are
the
inverting
diameter.
about the circle with ratio BC. Circle
With
diameter.
the diameter BC. Yeah, but still.
Oh, because if it were to go to a line, it should pass through the center, right? But the center M does not lie on the circle.
But then where does it go to? Then there's a hole at M.
There is a hole at M, indeed. So
What?
B Humpty
Yeah.
C. B Humpty C is bad. I know that B Humpty C is bad.
Okay, wait.
We won't do this inversion. I don't think this inversion is good because B Humpty C is very bad.
Projected looks so good, but unless you figure out how you project it.
Yeah,
No,
we need.
I think we can still work with that inversion. Like M, we need MJ times MX to be MB square or MC square. Okay, lengths don't help.
Wait, do I remember my angle change?
Okay, but if we draw the median, does that help?
Yeah, I will do that. Why not?
Right, because
Okay,
then
X
it'll go
lies
through
on
the
the Euler
center.
line.
Bro,
Oh God.
X lies on the Euler line, huh?
this thing just has some personal beef with me at this.
With us.
Yeah, true. Okay. So
Oh.
What's going on? I don't get it at this point.
no,
Okay, I
it's like
think I get it.
mathematical continuity. It's like the GeoGebra is rather accurate with mathematical continuity, so it takes the tangents away.
So it's not exactly its fault.
Yeah, it's just mathematics. It is its fault. Why are you working with limits? Just work with the actual numbers. Like why limits?
Okay.
Yeah, like if you can't define tangent, like why do you want to define tangent as the secant as the distance approaches zero? Like just define it to be a perpendicular one. Like ninth grade geometry is much better than other geometry.
Yeah. Have some real beef, I think, at this point. Oh, YBW looks collinear. I don't know why. I'm
What?
probably like YBW. I'm probably like stripping, but
It's not. It's not. I'm pretty sure.
yeah. But everything looks collinear for some reason.
It's at this point everything is essentially
Multitude of points. Multitude of points.
indeed. Okay, wait. Let's leave this for wait. We should be able to we should chase this, yeah. It should not be hard. Uh okay, famous last words. This should not be
Okay, where should A go under that inversion?
okay, that inversion is just horrible. A goes to the Humpty. I know that much. A goes to the Humpty.
Okay.
Okay, right.
But that's bad. That's bad.
And P just goes to some random point.
Yeah, so we should not do this. We should not do it.
Okay, how about BIC inversion?
Yeah, that is a possibility. Let's see. So A goes to a good
But
point.
where will J and X? Okay, so okay, fine. Yeah, that's a good idea.
Okay, J.
Yes.
Oh, right, but J won't go to X, right? How does that help us?
No, J might go to. Okay,
It
where
doesn't,
will
but
J
we
go?
still might be able to show the collinearity. It doesn't help us in the cross-reference, but we might be.
But we already know that. We already know the collinearity, right? Oh, right, that. Oh, APJ, right?
Hmm.
Wait,
Okay,
Okay, we know P goes to S under that inversion.
just a minute. Okay.
Oh.
Yeah.
Right, so we want to show APJ is collinear.
True.
We know where A goes, we know where P goes.
We don't know where P goes. Where does P go?
To the Sharky Devil point.
No, J goes to the D goes to the Sharky Devil. P does not go.
What?
under
Oh.
BIC inversion, right? Like that doesn't
Yeah,
happen.
under BIC, D goes to the
Okay,
Sharky.
what about the chances of like in-circle inversion? What are the chances of that working?
I don't know. We need to try it out. Okay, how would you define the symedian? I believe reflections are preserved. Hopefully.
Yes. The reflections are.
Okay, it's not good. It's not good. Wait, let me switch on the lights. It's dark.
Is inversion on the whole good?
I think I was thinking of like ratio. Why is ratio? There should be a ratio. Like my brain's
We do
unable
not
to.
know people.
Playing with
Let's
lens
say-
is going to be a bit hard.
True, but like we might be able to cross ratio chase this, right?
Yeah.
Okay.
So
Okay,
I'll-
Mandar, good news. You have not, your internet has not gone bad for the last 15-20 minutes.
don't jinx it.
Yes, I'm so proud of that. I'm so proud of that. Like my internet is the only thing I'm proud about now.
Not even your GeoGebra.
Okay, just curious. Can we like somehow check that XBJC is like harmonic? Can we check so that we are not proving false
Oh,
claims?
no, it has to be true, right? Because like just project through S, then
Okay.
uh
Okay, yeah, it's harmonic, yeah.
yeah, it has to be harmonic.
Wait. So now, can we prove something else other than APJ? Which
Wait a minute. Why do we have to show that? Okay, no, wait. Why do we have to show that it's
What's the use
harmonic?
of?
We know that it's harmonic.
Yeah,
It has
we
to be
know that,
harmonic.
but what can we do after that?
I think we're taking AX, AJ, AB, and AC. That's how we're using it. But I don't know how that helps.
Wait, what do we have to show? We have to show that APJ are collinear, right? APJ is collinear.
Correct. Is that the problem you made for Lamau Revenge?
No, that's not the problem I made for love.
Okay.
Okay, what's good about P?
There is
AX BP also looks cyclic. Why is everything looking cyclic at this point?
What's looking cyclic?
AX BP. I'm just
AX,
BP.
EP. Oh,
It looks cyclic, but it's probably not.
it could be. I don't know. It
maybe not, maybe yes.
It's probably a false claim.
Wait, if okay, no. Okay, it could be. Okay, no, right? Because see, if AXBP is cyclic, AXCP should also be cyclic because PX and those are
Correct.
Yeah,
Yes.
okay.
yeah. So
Symmetry.
symmetry, that would be
Yes,
cyclic,
yes.
but AXPC is certainly not cyclic.
Convex now.
Yeah.
Yeah.
Okay, no. God, my brain's not working.
True. It's a hard config. It's a hard config. Okay, so people, you go on proving this. I'll draw more conflict. It's so much fun to draw conflict.
Yeah, fine.
Right.
How
So
much
for
are we trying to stretch? Like 7:30ish?
I do not know. Like it's I'm pretty comfortable. Okay, I just have to do math after this as well. So
Hey,
if
please, we can stretch it like Ronit, I don't know, but I would love to stretch it a bit.
Oh, I would love to. I could go till 11 if I wanted to.
I could go to like 9.
yeah, it's fine. We should just do this. Okay, can't go till 9. I have like a class at 8:30. So probably
Okay,
leave
so
at
8:30 or 8 o'clock, whatever.
yeah, I have to have my dinner. Sadly, human needs. If I was not human, we could switch it to like stretch it to yeah, sadly human needs. Okay, not even human needs. My mother would eat me if I don't eat my dinner. Okay, look, I think this sounds very wrong, but like you get the point.
Okay,
Right.
so
Yeah.
XBJC. Okay, so XB into XC is equal to XS into XA. So like JB into JC. Huh, could we do something with that?
Wait a minute.
Okay,
What good things does the median actually even give us?
wait, let me
Nothing.
just do that then. Okay,
Life
so
is just
XB
bad,
into
sir. Life is
XC.
just bad. Simedian
Uh,
only like one thing.
what is harmonic? XBJC. Okay, so
Huh.
I forgot what's the order of points. Oh God.
No,
X.
XGBC. Okay, whenever you have something harmonic, pick the first two and then the second two.
Okay, fine. So
First point, third point, second point, fourth point from the
so
left.
just checking because I tend to mess this up. So BX upon BJ divided by CX upon CJ is equal to -1.
Yeah.
Okay.
Okay, people, I have a proof, but you likely won't understand it.
Go ahead.
Okay, no, you will understand it, but you will have to take my word for one thing. Are
What is
you
that
willing to take my
assumption?
word for it? Okay, wait, let me open a new GeoGebra for this because, like,
Okay, I get it why you want to do that.
yeah. So,
I just opened the graphing one always. Like I hate that.
GeoGebra, no, GeoGebra is like, wait, why do you hate GeoGebra? GeoGebra is good. It
No,
can make
like GeoGebra graphing. It always opens the graphing first. So when on
ah,
the phone, you
yes,
have to like twiddle with the top console and hope like you don't press anything else.
yes.
No,
Ah.
you can just select geometry and then go to view
Hey,
algebra
that's in the
also.
laptop and stuff. No,
Like,
phone,
bookmark
phone.
GeoGebra Classic now. Just bookmark.
Phone, sir. Phone.
Yeah, that's what I always do.
Why
I
are
just
you
write.
taking GeoGebra on phone? Don't do it.
Like dinner, like when you have lunch, no, like if you're like really crazy, I just open GeoGebra.
It would be better if you just finish your lunch before that.
Nah,
That's
like
also true. Like I am pretty sure I would have to face consequences if I take my phone to dinner. That would be sad. Either way, people, look at this. I'll show you some stuff here. This is the ortho center, and as I'm drawing the ortho center, you can probably guess where I'm
midpoint of
going
BC
with
will
this.
draw. I'm just guessing.
Viewpoint.
2 point, indeed, 2 point.
Midpoint
D.
of BC as well. I think you'll draw.
I won't draw that, sadly enough.
What the heck? I
Yeah.
thought that's
Right. Then you
synonymous
take
with 2 point.
circumcircle, intersect,
Uh,
get Q.
A, E, F.
Okay, we're doing 2 point now. Huh? Okay.
Yes, this is a small thing about 2 point, but it is a thing about 2 point. Yeah, prove this.
Oh,
But
collinearity.
Concurrency.
concurrence. So
Sorry,
prove.
Radical
I
axis.
always get mixed between the two.
Radical axis.
Yeah. See, like that is why you should work in projective spaces because concurrency and collinearity are essentially the same due to duality. So you can just say that I was working in a dual, and yeah, I was correct.
Like radical axis just works. Like what?
Yeah,
Okay, let me
exactly.
see.
Radical access just works. Beautiful.
Yeah, I remember proving this somehow.
Okay, I will just show you how
You
the
also
sum
have
of
like one more
this.
cute thing. Like it was there in some India TST. But I think 2010. I think it was
All right,
2010.
okay, I see what you mean. Yes, fine. Cool.
Yeah. So now this is called the X point. Okay, this intersection is the X
Okay,
point.
this is X point. Fine.
Yes.
Okay,
Right.
that is called the X point.
Now look at this. Look at this. Y is the X point of DEF, right?
Prove.
Yes,
Okay,
that's what
let's see.
that's how
We
we
haven't
defined it.
proven it, but just take my word for it. In fact,
Okay,
we
we
can
take
prove
it.
it after
We
this.
trust.
We'll prove
We
it after.
trust you. We trust you. We trust you, sir.
Okay, see, yeah. Okay, now look at this. We had that XJBC is -1.
XGBC -1.
Don't when
Fine.
we trust you, we trust ourselves that we can prove it later.
Okay. Let Mandar continue. XGBC -1.
take perspectivity from A and send the line BC to the line EF. So X goes to Y, B goes to F, C goes to E, and J goes to some point we don't know. But observe that if
Oh,
I
right. Oh, damn.
like just here, yeah, exactly, you got it right. So yeah, that was
I
that.
didn't. Please explain
Yeah,
what.
I'll just show you. Rename. What is this? I to Y. Yes. So see, YDBC is -1, right? YDBC is -1. Now observe that we have the X point and we have the 2 foot of perpendicular.
Okay. Oh. Okay. Got it.
Okay,
It
let's
should
just
be
prove
the
that
foot
it's
of
X point now,
perpendicular,
right?
and that is P. We have shown that
All
it's
right.
P.
Harmonic is considered. Okay. Yeah. Cool.
Exactly. So like YPFE is also -1 and YP dash FE is also -1. Hence P and P dash are the same. Okay, that is good proof.
That's a cool proof.
Indeed.
So
And
now
it
we can
like
just
heavy.
prove Y is the X point. So how do we do that? H.
Oh yeah, we have to prove that Y is the X
But we
point.
actually didn't use the fact that it's on the median. Oh no, that's how we prove
Yeah, that is how we prove that XJ.
harmonic thing, right?
Yeah. Okay, people. Next thing. Prove that APJW are consecutive. Go on.
AP. What?
W also lies on this line. Prove that W also lies on this.
Oh, okay.
Okay, what is W defined as? Like, how are we going about defining it?
There are multiple ways of defining it. You could take it as DMMA cap W. Okay, I'll just like give a quick revision on W. So W is the intersection of ABC and TSPD. Okay. Oh wait, it's the intersection of this and this. So we might be able to project the cross ratio in some good way.
Yeah, probably.
So TSPD cap the circumcircle is W, and it also lies on this circle because of obviousness. W is NAW is perpendicular to TMA. Okay, that's all we know about W. And now we have to prove that this line exists. It's a beautiful line, and I'll show you like a bunch of more properties about it.
Okay, so what is A with respect to TMANA? Like, do we know that?
What is A with respect to TMNA? We do not know, and that's okay. I do not know what that is, and I do not remember the proof of this either. So let's hope we find it. Let's hope we.
So W is just the intersection of
NAD and TMA.
and we already know that that's 90. They're perpendicular, right?
What?
That
we know it's 90.
ND and TMA are
NAWMA is 90.
Yes. Wait, we don't know WMA is. Wait, WMA. Wait, Ronit,
D is
could
the
you
ortho center. D is the ortho center, nah.
D is the ortho center, so NAWMA is 90. Then
Right, we're trying
and
to
we
like figure out.
anyway know that because W is cyclic and DMMA is 90.
yeah. But how does that give you AP? This I'm sorry. I
Yeah,
don't
well,
get.
just give me a second.
Ronit, what was your proof?
No, I didn't have any proof. I was just looking at.
Okay. Cool. Okay. We might be able to chase this out as well somehow. I don't know.
I think we can do the harmonic thing again somehow.
Yeah, that is what I was thinking as well. So this
Okay,
time we
is
project
XSMW cyclic?
XSMW.
No, XSDW cyclic.
XSDW. It is not.
It is not.
D is okay. No, wait. TSDW. Oh god.
That is cyclic.
That's horrible.
Yeah,
I was trying to like
is
projective from there, but
that is indeed horrible. That is indeed horrible. So see, we could project through A now.
I was thinking of project through A.
So we need we need the like inverse of S in this, like the harmonic conjugate of S in the circle, and we need to show that that's W. Okay,
actually, we also need the intersection of AX and TW.
AX and TW.
Right.
I don't know. We might. I'm not sure.
Like if we draw that and the intersection is AM and TW, like just trying to reconstruct the pencil.
But is there a good projection over there? I don't think there's a good projection.
No, because you have to define 3 new points.
Yeah, it's bad. But okay, we could project from line BC to the circle through A. X just goes to Sharky, B remains at B, C remains at C. We need to show that BC SW is -1 somehow.
We have to prove that BCSW is -1. Okay.
Yeah, that would give the implication.
Wait, isn't that by like if W is on the circle, then we're done, right?
Oh, people, I think we are
We're
done.
done.
We are done.
Right. Because
Okay, what's
W is
your
on the circle.
yeah?
If W is on the circumcircle of ABC, S is also on the circumcircle of ABC, we're done.
No, that doesn't work because you have to show that BCSW is -1. You haven't shown that.
Okay, just give us a second, wait.
Yes.
Is that by something I forgot? Like maybe you have like 4 points on a circle and they're like harmonic or something.
Wait, why do we need harmonicness again? Okay, yeah, okay. We need harmonicness. Okay.
Okay,
no.
I think I got.
Just a minute,
Isn't it
Nishant.
right? Isn't that right?
Nishant, just a minute. Ronit, that is not correct. Not all 4 points on a circular harmonic. That's false. I'll just show you here. Say, okay, so 4 points are like concyclic if and only if the tangent property is there. So in this case, like BFEC is not -1. Okay, that's false.
Okay.
Yeah, it's not
any 4 points. Like if you have 3 points, there's only 1 point which creates that harmonicity.
Indeed, that's true.
So if we start with
keep on the discussion, I'll get water.
Yeah, sure. So now,
like if our 3 points are A, S, C, can be kind of pinpointed to D.
okay, wait. So what harmonics do we have? X, B, J, C. Okay, what? Haven't we done that? Project through A, J goes to W, X goes to S, and A goes to C.
J goes to W.
Wait, yeah, I think I got it. Yeah. So J goes to W, X goes to S, and B goes to B, C goes to C.
That's what we did.
Yeah, but we don't know that J goes to W. We don't know that.
Oh, wait. So S
that is why the line is solid. Okay, so
Yeah.
you people are completely on the correct track. Should I give you a hint or something? Do you want a hint or like want to try?
Just 1 second. Like you can give it in like 2 minutes. Just give me like 2 minutes.
Yeah.
Go
I'll
on.
go for the hint in 2 minutes also because I'm like not good at harmonics. Like I just saw one Krishna lecture and I'm trying to work out this.
Okay, I am also very bad with projective. Like the only projective I can do is MMP. Because like you don't actually have to chase ratios there, you just have to chase processes.
So method of moving points. Okay, I should study that.
Yeah, method of moving points is like goated stuff. You can
like you can make like if you make like a small error, your proof is done for.
Yeah, that is true. Okay, see, so some fun statistics. In 2023, MOP, everyone knows what MOP is, right?
Right.
Yeah. So the total number of MMPs done, guess the percentage of correct MMPs.
MMPs?
Method of moving points. The number of solutions with MMPs, like say that there was X number done. What is the total number of correct things? Okay, we have a guess in chat. I don't. What do you mean? Oh yeah, you don't have to know MMP. We won't be using MMP. I'm just asking
My
you
guess
to
is
guess
like 25%.
30.
Okay, like okay, sorry, Mahimarnob. Am I saying your name correctly?
Mohimarnob, I think.
Mohimarnob.
Okay, I can't pronounce.
Yeah. So Mohimarnob got it correct. It's 0%. No person got it correct in the 2023 MOP and MMP solution. Everyone picked it. Got it wrong.
Wow.
Yes.
How many is that? Like 60 people?
Yeah. Bhai, 60 of the best USA people. Not 60, 200. USA takes 200. I think roughly 200.
USA takes 200. India should take more there.
Nah, India just does not have the. Leave that. India did not go to RMM this year.
And why?
lack of funds.
Oh,
Apparently.
right. India has
Yeah,
that.
we were eligible, but we just did not have the salary.
Okay, so now let's.
Yeah.
Oh God.
Anyway, test proof. So it's been 3 minutes. Do you want to hint?
I
Yeah,
mean, we
I'll
were
go with
talking the whole 3 minutes, but yeah, give us the hint.
Yeah, true. Sorry. I will be more careful next.
Yeah,
Look
I'll
at
go for the hint.
look at a projection through J. Look at a projection through J.
J.
Yes.
S goes to G. B goes to C. C goes to B. What?
Yes. True. And C. Look at this. We to get that.
Okay, huh? Okay, so B, G, C, A is a harmonic.
Yes.
So since S goes to G, B goes
Yes.
to C, C goes to B, W must go to the harmonic conjugate of those, and which is A. So A, J, W are collinear.
Yeah. Great.
Okay.
And
Did you get it, Ronan?
damn,
No,
why
I have to learn more projective before I get that. I look at the recording.
Oh,
Oh no, it's just projecting through J.
it's just projection through J. It's not any hi-fi thing. But see, we know that like project through J, so S goes to G, right? As we proved before.
Right,
Correct.
right.
B goes to C, C goes to B. Correct. And hence the other point A must go to the harmonic conjugate, and that's W. So
Oh, okay.
cool. Now let me look at another property that I want to like exploit here. See this T dash. It's absolutely good. Okay. Let's see.
Let's do something on that. Come on.
T dash is like this point W is T dash. This
Oh
point W
damn,
is.
why? Okay, that makes me up. Fine.
Yeah. Sorry. But it is indeed. Okay, wait. Let me instead draw a line because lines are superior to line segments. Technically,
Yes.
they have the same number.
True.
Come
Wait.
on, come on, Mandar.
Yes, Mandar, that's true. Ronit,
See, when
Okay.
you're drawing diagrams, it's better to draw line segments. Otherwise, it'll be so.
how do you know the intersections? You won't know
Oh,
intersections, right?
no. If you're working on GeoGebra, firstly, if you're making like a problems diagram on GeoGebra, just don't. You should never do that. And in case you are doing, you like tried it a lot and then you're like desperate for a good diagram, use segments always. Never use lines because lines give out information. But if you're studying config on GeoGebra, lines are superior.
Wait, why are you making problems? What? We are not, we are.
Solving problems. Now, like if you're solving a problem on GeoGebra, use segments and not lines. Otherwise, you like get a lot of extra info out.
It's
Like
my time to laugh
don't
now,
you use
Nishant.
GeoGebra like only when you don't like get anything on paper?
Nishant, it's my time to laugh.
No, like that's true, right?
Okay, wait. Okay, also, I was just like randomly thinking. I said that they like line is superior to a segment, but they have the same number of points, right? This reminds me of a problem. Uh, wait, let me. Okay, wait, no, right, no, not
That's
a
a
problem, right?
fun kind of.
I think okay, so people, I'll just give you a question. I think 2015 or India TST 2015 day 3 P3 or something, I think. Wait, let me just okay, sorry, I'll just find it in a second. 2015.
2015. Okay, damn it. I didn't print it. Oh God.
Yeah. Day 2 P3. Prove this problem for uncountably infinite graphs.
Hey, wait, Nishant, didn't we do what? Nishant, can you just look at May 7 first problem? Didn't that come in an IMO we did together?
Hmm. Yeah, they copied it. I don't know. I
They
know.
copied a problem, bro.
They copied a problem from the IMO.
No, they do copy that. Like day 1 P1 is like IMO problem, or I think it's
Yeah.
an N1
Right, we did it together.
problem.
It's an N1.
Yeah, it's 2014 N1. This is 2014 N5. This is 2014 N4. This is 2014 G3. And is there more stuff?
Like those days they used to copy. Like now I don't think they copy anymore.
This is C1. This is C1. Oh no, now India is like a lot of people who can just propose problems, so we do not need SQL.
Right.
That's good. That's like quite a
Like we
flex.
have
Because,
more people than funds at this point.
yeah, and the point is like very few countries can actually make their own TSTs. Like they can
Yeah.
actually, yeah. So it's good
I
thing
think
that we.
probably not more than the top 7. I don't.
It's
I
not
think
Everything.
more than the top 10. Not more. I
top
don't
10,
think more
yeah.
than like 10, 15 countries can.
Okay, now what do we have to prove this time? Like now?
Yeah, let me find that.
Yep, take it out.
Uh,
But
By the way, Mandar, do you want a G-Sog after this?
yeah, surely. Great. I am totally
we could
down.
like discuss some cool geo problem.
Not Geo, bhai. Okay. If you
Okay,
want
yeah, we could do like beside geos.
We can.
Okay, like please, we'll do this problem because I haven't been able to do this problem for like a lot of time now. So yeah. Anyways, so okay, easy problem. This prove that this like highly dotted circle actually exists, and it's honestly easy for this case. It's not easy in general, but it's very easy in this case.
Okay.
So yeah, go on, people, prove it. It's your task. Prove that this like largely dotted circle exists. And like Gmeet is actually superior to Zoom because I can actually like share one tab. If I have to go to the other tab, I won't have to worry that people will see the other tab. Because
Yeah,
like
we're gonna do the G-Solve on
Okay,
Gmeet.
what is line SF? Anything special about line SF?
SF, no, it's not special and it's not drawn.
Like no, why draw it and just see? I'm just curious.
Okay, I'll add.
It's
Yes.
random.
It's not.
No,
Okay, wait, does it lie on this intersection?
No.
It doesn't. It doesn't.
it doesn't. It just misses.
Okay, and
See,
people
once you have
promise to
so
give
many points, everything is just
Okay, can we
is
zoom into that
either
SBF?
collinear, cyclic, anything.
what?
Can we zoom into that SFKX a bit? Like,
SFKX. Yes.
yeah, that's it.
Uh,
The hint for this will come at 7 exactly, and I won't speak over till best of it.
Thanks. Okay, can we use like Mikkel's theorem or something?
You possibly can. I don't know how you will, but yeah, go on.
I was thinking if we could use the parallel line somehow. Like, if suppose we wanted to show angle XKS is equal to angle XFS. If we wanted to show that, then we already know that angle XKS is like goes through some point in YE, and then angle XFS is equal to angle YFX plus YFS. YFX is equal to FXK, and then I don't know, something like that.
IFX equal to KXF. Okay. Then you'll prove KSF? Well, I have no idea. That's
Point is, I think it's going to be an angle chase.
but how? But how?
Oh no, it's
Okay, ASF. What is angle ASF?
ASF. I can't find F. F. Yeah, ASF.
90
is-
minus, okay, 90 plus A by 2. So
It's 90.
angle XSF is 90 plus 90 minus A by 2. So
No,
angle,
90 plus A by 2.
yeah, so we're done, right? By angle chase now.
Okay, yeah, that works. Great, people. Nice.
Hey, wait. What? Let me think.
Pick it up.
Yeah.
What do we have to prove next?
Okay, yeah, got it.
Yeah,
Okay.
okay. And another just like a power of point chase. We
Okay,
know
what
that
is?
triangle FKI is tangent to AI, right? So AI
Okay.
squared is equal to
AF into AK.
AK, and we had
Oh,
shown that
right, yeah. Oh, that's a solid.
Oh, that's a nice one.
yeah, it's quicker. I don't know, like angle chase. Like when I
Okay,
have
both are
multiple,
pretty fast.
yeah, both are very easy. So I'll give this thing the normal designation now. It won't be discriminated against anymore. Yeah. So okay, now at like we have essentially just exhausted all of the config. I'll soon introduce the other point and the Apollonius circle. But yeah, life is
You say
what
you have
is
like some CMO problem, CMO
A by
problem?
2 is angle A divided by 2, like the half the measure of angle A by 2. Yeah, what were you saying?
Didn't you have some CAMO problem? What was I?
Oh yeah, that is the CAMO problem. We could do that. That I think uses, but that uses the Q point, not the shut.
Oh, okay.
Okay, then we can try it later.
Yeah, maybe I might as well take another class on config. I'm not sure.
Very cool.
Oh, it's not done yet.
Okay. XWJH. Okay.
It's not
Okay,
on me.
no. Wait. Okay,
H-
yeah.
H HWKYX is like.
XH. Okay, no. Let's see. Let's not get ahead of ourselves and just look at it. Okay, this one.
Like XHW.
It's H. This. Okay, what am I doing with my life? I think my life is a bit lie.
Okay, HMAM.
Wait. What?
What is H? Like,
Wait, what am I messing up here? Oh, H, leave H. What is X here?
that's X.
Our same X.
Yeah, it is the same X.
BIC and
This is like BIC and this is the other circle.
ADT.
Oh, this point.
This point only.
Hey, didn't you mark that point?
Isn't that all? Wasn't that already AH?
You marked it as H earlier.
H was this one. H was this.
Oh, okay.
Okay.
And this is still false. Yeah, this is why I don't like this.
Right. So what is going on?
Yeah, I don't know what's going on, sadly.
AID. Okay, AID circle.
It has to be this point.
Yeah, it
Wait.
is AID.
It is
And then that
AID
is
circle.
X.
Your I dash is like on AID circle.
What?
I dash is on AID circle.
And that is H.
H,
Yeah,
yeah.
no, that was not H. This was
No,
H.
AID circle we haven't drawn, right?
Okay, wait, another problem.
No.
Like first
Oh, right,
proof
we
this
haven't
and then-
drawn AID. Oh, we haven't drawn AID.
Wait, have I not drawn AID?
No.
Wait, so okay, AID. Okay, wait, sorry. AID is actually the Apollonius circle. Okay, that's.
Okay, I forgot what the Apollonius circle is.
We'll come back to that, but that's not necessary right now. What is necessary is this thing. Yes. So
Like,
we
I can't
introduce
understand anything.
this. Okay, wait. I am also not understanding anything. What is happening? What?
All right, Z. You want Z?
Wait, I don't want Z right now. I want TS. What the hell is happening here?
What is the third point you tell us? TSD?
TSD, huh?
Okay, wait. This line.
TSDW.
So we don't. Okay, we don't want Z. We don't want Z right now. We want. Wait, what is this circle? What is this circle? It's I dash.
What
Okay,
is
yeah.
I
This is an easy one. Just prove it.
MIX.
This is an easy one. Just prove it.
Okay,
And
XIMMA. Okay, that's what you want to do. Fine.
this is a very easy one. Just prove
Okay,
it.
angle XIMA is 90.
90.
And
Yeah,
XMA
90.
is 90.
Precisely.
XMA.
Great. So wait, everyone got that right?
Yeah. Angle
No, wait.
angle XIMA is 90 and angle XMMA.
Because we had shown that xi is tangent to this, right?
Yeah.
Like what was it? Common tangent, no?
Common tangent, indeed. Now, what else do I want to show? Is there something else, some other good stuff I'm missing out on? TS. Okay, we have introduced this circle. Okay, what is this circle? Oh, we haven't. Okay, yeah, this circle is a very trivial one, but yeah, I'll introduce it as well. This is also easy by what we have shown till now. This is also easy.
ASJM?
ASJM. This is not difficult. Just do it. Like, trust. Just do it.
Okay, XJ into XM is equal to XS into XA. Okay. XJ into XM is equal to XB into XC somehow it prove, which is some sort of.
Just remember what all we have proven. Just remember what all we have proven, and that will itself be enough to show that this is true. Okay, will it be enough? I'm not sure anymore, but yeah, let's hope that it's enough.
Okay, so xj into xm is equal to xs into xa. How do you prove that?
No, I think we need to prove angle AMB is equal to angle ACG.
AMB is ACG. Wait, why?
Because angle ACG is 180 minus angle ASJ.
ASJ. True.
Fine.
Yes,
So,
that's clever. That's clever indeed.
so angle ACG must be equal to angle AMB. How will you get that?
Yes, that is indeed true.
Spiral sim?
I am not sure
No,
how
you
you
don't.
did that.
You don't have a center.
And we can't spiral sim because under spiral sim, if M goes to C, then B also has to go to on the same line, but B is going to the circle. Okay, no, it could exist. Spice sim, it could be spice sim. I'm not sure. Is this not just true?
Okay, what do we know about G again?
Wait, I'm pretty sure there is like an angle chase proof, like power of point proof to this. I remember power of point proof, but yeah, your point is also very valid. We should be able to prove that.
Actually,
So
A and
XS
B
into
is not
XA.
quite good.
A and B is not good, but it's the semidian, so it has to be good. Oh, okay, I got it. I think I believe I got it.
Just give us
Yeah,
a
yeah.
second. 1 second.
I don't remember any properties with semidians.
Yeah, I'll tell you how that's done. But yeah, do it,
1
people.
second.
Have
1 second.
time. Okay, there is a power of point proof, which my original proof was power of point, if I remember correctly.
Okay, we have angle ACG is 180 minus angle CAG and plus minus 1 angle AGC.
Okay, I'm not getting any of your angle chase because it's too fast, but go on.
Okay, right. No. Look at triangle AGC.
Yes.
We know that angle ACG is 180 minus angle CAG minus angle AGC, correct?
Yes.
Angle AGC is ABC.
AGC is ABC, yes.
And GAC is what? GBC? No, GAC is what?
GAC is BAM.
So you're done.
Yeah, precisely. That was it as well.
But how do you know GAC is BAM?
The median
Because
median.
yeah,
Oh, right.
semidian
Oh,
median, because
right.
AM is yeah.
Good
How do you power of point this? Let me see.
Yeah, I also want to look for a power of point proof because power of point is arguably better than anything else.
Okay,
In
but
fact,
take power of point at X.
yeah, that is the idea.
XS times XA must
Okay,
be
xi
equal to
squared
what?
is equal to xs into xa.
Yes.
Is equal to XJ times XM. That's what you
Okay,
want to say.
X and J. Okay, we are done. Yeah, cool.
And XJ times XM is what?
Wait, what? How are we? Im is perpendicular to xi? No, wait.
No. See this, people.
No.
Xi square. We want xi square equal to xj xm, right?
Correct.
No.
Now we know that xgbc is -1, correct?
xgbc is -1.
And then
Oh,
there is
okay,
like,
I got
and
it.
M is the
Okay.
midpoint of BC, so that property comes in.
M is the midpoint of BC. What property comes?
Okay, I forgot what property comes in. Sorry, just a second.
No, but I
Okay,
think it's something like that only, right?
But how did you get XJ times XM is equal to XI square? Why do you want to show that?
Okay, because if we show that xi squared is equal to xj into xm, we would get xi square is equal to xs into xa, right? So that would give this the
Okay, xi squared is xp into xc.
xi squared is xb into xc. Yeah.
So xj into xm, bro. What the hell?
Crazy. Wait, but let me look
Oh,
at
wait.
this.
Oh,
XB to
right.
XC, J is the
X.
median, something like that. Like J is the median point on BC. So,
No, J is not the median point. J is
oh, wait,
not.
yeah, it's G. Oh, sorry.
It's right.
Okay, xs times xa is equal to xb times xc, which is equal to xi square.
Yeah, we want that. We want to prove that.
Okay, fine. Do we have any circle with J and M already?
Yeah, I don't know.
Wait. So we would also get that XB, XC is XJ, XM, right?
Huh?
And that should be something, right? Like something.
Can you use harmonic midpoint? That's exactly what you were
Yeah,
saying.
that is what I was thinking as well.
Yeah, but it is a point at infinity, right? Of XC or something.
No,
Midpoint, yes, point.
we don't have to use that.
No, the
Wait.
point is we're not going to
Are you people able to see my screen? Okay, yeah, that actually works out. Okay, wait. Are you people able to see my screen?
GeoGebra?
like GeoGebra.
Okay, you are only able to see GeoGebra. Okay, wait. Please move. Wait, what do you want me to move by? Wait. How do I switch my share? Share. Screen. Share. Okay, people, look at this. I think you should be able to see a PDF right now.
Yeah,
Yeah,
no, yeah.
Right.
read problem 1, and like this is like 2. Okay, we just assume that it's true. It's well known. And it's a homework for you. It's a homework for you because I have
Okay, yeah,
proven it.
okay, yes. I know this. I
Yes.
remember.
So look at the third property.
Why?
Wait, what? Ax py on points let m be the midpoint of AB. So the following are equal to A.
Okay, just look at the third point. Okay.
Fine, that's it. Okay, right. Then we got it. Yeah.
Yeah, because we already know that XJBC is -1, so we also get the third point for free. So wait, what's the other?
Wait, what's
Yeah,
the third point? What do we get as the third point here?
this by third point I meant this, that y into yb is yx into y.
No?
Okay,
Yeah.
okay, yes, that's
Yeah, so we get that xp into xc is xj into xm.
yeah.
And that's equal to xi square and yeah, done.
Yeah, done.
You actually don't even need to include xi square.
Yeah, we can directly. Oh yeah, true. We don't
You
have
can
to.
directly just shoot it.
Yeah, true. That's true.
Like Siddha, you have Siddha xs times xa is equal to xp times xc, which is equal to xa times xm.
Bus that works. Okay, wait. I think there is another thing I'm missing here. Okay. See, this is a very trivial thing, and I won't note it because just like okay, I won't even note it. Leave it. It's trivial. It's trivial. Okay. Now, is there
Wait,
anything
what
else
trivial?
left? Okay, wait. Oh, okay. This is a beautiful circle here. This is a beautiful circle. This is very easy to prove, but it's just beautiful, so I'll point it out.
Okay, I got it.
Yeah, that only. Rename H to
Okay, right. So angle AHP is equal to 90, which is equal to angle ASP, and we're done.
yeah, this small guy. Yeah, this small guy just pops up. It's beautiful. So yeah,
Like as soon as you made that point, I'm like, yeah, okay, I got it.
exactly. So we have this small guy here. We have this guy here. This big guy. We also have the big guy. We also have the big guy. And we also have this small guy. Do we have the small guy? Yeah, we do have the small guy. We have this person as well. Do we have? Yeah, we do have this
I think we
person.
exhausted. Oh wait, no, that's not.
No, we have not introduced Z yet.
Z has
there is one big circle which is like 1, 2, 3, 4, 5, 6 points on it. So yeah, one
is left.
Pascal's, huh?
Not even Pascal. It's not. Okay, wait. Another property that I just think is true and found out right now. I am not sure about how to go about that. Yeah. Okay, this is something I just found out, so I am not sure how to prove it. But yeah, so their intersection is apparently on the circle. Okay, it's not. Hi, yeah. Hi. That's that.
Yeah, I'm just curious. Pascal's on. And just could you like go up a bit? Yeah. Pascal's on NaAs W. Okay, the G is not on the circle. Okay, the G is on the circle, right?
Yeah.
GMA.
Yeah,
What is
yeah.
that
Oh,
give us?
that Pascal would give you that JDM, the line BC.
How
It
does
would
it give you M? I don't get it.
it somehow gives you M. I don't know. I did that Pascal. It gives you
No,
weird stuff.
GNA intersection AMA.
It
Bro,
gives you J. It gives you J.
no,
And
the GNA, okay, it gives you the angle bisector point on BC.
yeah, it will give you the
So
angle bisector.
GNA lies on, angle bisector point lies on GNA.
It will give you it would give you the line BC essentially. It would give you the line BC. Yeah, nice. That's pretty cool. Wait, is anything else left in the diagram?
Nothing. I don't think so. No.
Yeah, hopefully
fine.
not. I also want to just introduce the last point by now. And the last point, the last chase is very, very easy. It's not at all difficult.
The last point is obviously
Wait,
the
why
last
have
letter in
I
the
drawn
alphabet.
this point? Why have I drawn this point?
And the last point has to be the last letter on the alphabet.
That would be extremely fun. Okay, I see why I have drawn that. Okay, and wait, let me just change it to dotted. How do
Yeah,
we
this is
change
a
it?
long OMC lecture.
Yeah, it's sorry for that, but it's like a config. What do you expect?
Like, no. I'm like talking to like if anybody is viewing it later.
Yeah, it is a long OMC lecture. We have that point. We have this
We've
point.
had 3 hours sessions before.
People, let's. Okay, so like brace yourselves. Okay, wait. I want to introduce another point. I don't know if this is useful. I don't remember this, but the tangent at A to the circumcircle. The circumcircle is given by C, right? Okay, not that apparently. Wait,
Tangent
what,
A to
is
the
it given by
circle.
D?
Yes.
Yeah, it's given by D and it's utterly useless. Okay, wait, I'll just write circle A, comma B, comma C. Yeah, it's given by D and it's utterly useless. Okay. No.
Mandar, the last point always has to be the last element on the alphabet. It shows that we've exhausted all other letters.
Yes.
Have we? I'm not sure.
Finally, we introduce. Okay, I'm not sure, but this is as extensively as you have to study this config. Like, you will not need anything above this.
We have no idea, bro.
Okay, so
No
first,
idea. Absolutely no idea.
delete this H guy. And now, we
Okay.
have
The GeoGebra didn't
tangent,
give us
right?
something.
Okay, M1. I have no
Wait,
idea. Is that M1? M1 IDW.
XI. Oh, damn. What?
Wait. XI goes through.
Okay, see.
Wait, XI
The,
goes through that point. Yes.
it
XI.
ideally should not. It ideally should not. It does. Damn.
What should
XI
not?
goes through BIC
Yes.
and what?
Yes. Okay, see. So introduce the other point that is tangent. Okay, wait. Okay, that's not X sides. Okay, it has to go through that point. It has to go through that point. Does it?
Wait, can you zoom in once?
I am not sure. It has to. Okay, see, it's a black point, so it has to be true. Else it would be blue.
Yeah, no, but it could be just 2 circles, right?
Oh, like XI. Wait, what? XI is equal to XH?
Right, it's true.
See, I don't think we need more magnification than this.
It's true.
XI is equal to XH. What?
Yeah. It's like crazy. Okay, so we have drawn the circle X centered at XI. We are essentially defining the other intersection. Okay. So firstly, prove that this guy lies on this circle. XIMAH. Okay, this is trivial. It obviously lies on that circle.
Wait, so XMA is the angle bisector of IMAH?
So X, okay, right. XHMA is 90.
Yeah. Wait, what were you asking?
Wait, so XMA is the angle bisector. Fine. That's 90. Fine. Rhombus. Oh,
No,
yeah.
no.
Okay, it's trivial.
Yeah, it's the other. Okay, exactly. It's trivial.
Rhombus.
So yeah, and it obviously lies on this, but
Kite,
that's
not
the
kite, not rhombus. Or like
whatever, doesn't matter. It's a kite. Yeah, it's a kite. Yes. That is not what I want to exploit. Now we will consider the Apollonius circle. In
centered
other
at Z or
terms,
passing through Z.
Can you remind me what the Apollonius circle is?
you do not need that for this problem. I'll go through that either way. But the Apollonius circle is Z, A, I, D, W, H are all concyclic. Prove it. You do not need any Apollonius properties. Yeah, like take 2-3 minutes. It's easy, and I can't really unzoom here. Okay,
Right.
and the good idea is that Zi is the tangent, is the
It's the
diameter.
diameter.
Yeah, just use that. Just use that.
Right. So
Okay.
so ZAI 90.
Okay, so D is trivial, then A is done.
People, wait. I want some more good stuff. You can see how MAWT is collinear, right? This is a
Right.
well property as well, but ZGMA are collinear.
Wow.
This is a much better property, and I think it's like a little hard to prove as well in some sense. I am not sure, but we'll come back to this property later. First, prove the
But that
cyclicity.
doesn't exactly connect to Sharky Devil.
It doesn't connect to it's not connected to Sharky Devil. I think it connects to mixed when you invert it. It connects to the mixed when you invert it, but it's not the Sharky.
Mandir, can you
No.
zoom it a bit? Just a bit.
Okay, so now D is done. Like D, we know.
Okay, right.
W?
Angle ZAI 90.
True.
90 and angle ZDI
Angle
is also 90.
ZDI. Angle
That's
ZDI
obvious.
90.
Then
Angle ZWI 90.
how?
Why?
No.
Why?
Angle TWI. Shit. No problem.
No, TWI is not 90.
Sorry, it's
No.
TWD.
Yes. So why should this be 90? Or why should... Okay, wait. I think Apollonius should be a much simpler proof here.
Anyway, just give us a second, like without a bolognese. Let me just try without a bolognese.
Right, like just angle chase it. I believe I'm pretty sure my proof was angle chase. You should also be able to angle
Okay,
chase.
what about ZHI?
ZHI. That also has to be 90, but we do not know why.
Does ZH go through that intersection of the two circles?
ZH go... Yeah, it does. It does.
Oh, then we're done, right? Then maybe that intersection is the diameter of that circle. Can you draw ZH once?
ZH.
No, it doesn't go through that.
Slightly off for you.
No, it doesn't. It doesn't.
It does
Okay,
or it
fine.
doesn't?
We can keep ZH for now.
Okay.
ZHI. What do we know about ZI? Okay, till now we know that.
Also, people feel free to... I don't know how that will help, but feel free to like use ZGMA collinear. ZGMA collinear.
Okay,
Like
what
this.
is ZA? ZA is a tangent to the ABC circle?
No, it's the external angle bisector.
External angle bisector. Okay, we haven't used that, have we? Or maybe we have.
No, we haven't.
No.
We have.
We have, right? Like A is perpendicular to ZA.
That's external.
Because of external.
Wait, XA is the exterior angle bisector. How? No.
ZA.
ZA.
Yes. Let's see.
So like ZAI 90, ZDI 90, ZWI. Okay, is IDWT is our collinear, right? Sorry, cyclic. IDWT.
IDWT.
Sorry,
Where's
X.
X? IDWX.
No.
Why?
Oh, it's IDWT itself, right?
It's
No, it's
no.
PDWT.
PDWT.
S. Yeah, PDWT and S also like that. Yeah.
Do we have anything with W and I?
Okay,
W.
WT looks parallel. No, it's not. It's not. It's not. Nothing.
Okay, the only thing with W and I we have is this.
Oh, okay. Then maybe something with W and A.
Okay, XT is parallel to AZ. No, IT is parallel to AZ.
Okay, so if we extend
Yeah,
ZH,
IT is parallel to AZ.
Why?
Then, oh wait, no, what?
No, IX is parallel to AZ.
IX is parallel to AZ. Okay.
And TM or TP is parallel to AZ.
If that is parallel, what does that give us?
Wait, and
TP.
does this intersection always exist? Uh, wait. Oh, wait, what is, okay, it doesn't. Cool. Uh, yeah,
Can you
Uh,
share the GeoGebra after this?
I will.
no, wait, I can't focus. Hold on.
Too many lines.
XPDW, TPDW. Holy hell. There's something with TPW there. TPDW, okay.
TPDW, yeah, it exists. See, yeah, like this is why you should do config. It helps your brain a lot.
Hey, hold on. Wait. Just give us a second. Okay.
Oh, right, TPDW. Oh,
Okay, so TP is parallel to AI. No, DP is parallel to AI.
wait, 1 minute.
So DP is parallel to AI.
Huh? Wait,
DP
where the
is
hell is P?
AI.
Okay.
Then DW is probably okay. Is a TW by any chance parallel to HZ? No, right? It's slightly slanting. Yeah.
TW
No.
parallel to HZ. Where is H? Where is Z? That I am not sure.
No,
Okay,
it's
no,
not.
it's
It's not.
not.
It's
It's not.
slightly off.
TW.
Let me zoom into this.
Like I think this is the only config that's this dense. I don't think any other config is this dense.
True.
Okay. IA.
There's nothing with WI,
IAZ,
right? There's absolutely nothing with WI.
DPP,
No, there's nothing with WI. Sad.
DWT is 90.
DWT. Yes, it is.
Huh?
Right, that is, yeah, by orthocentric.
Huh.
So DHZ is also 90. What?
Why? Yeah, DHZ is also 90.
Where the hell is H?
What
Yeah.
is going
Oh,
on? How is this working?
It's very fun stuff. It's this is why I like geometry. I don't know. I've been doing a lot of geo recently. Okay, no, I've just been doing a lot of problem solving recently. So, yeah.
DX.
Okay, wait.
DX.
I'm pinned. I don't like. Why am I being pinned? How do we remove pin? Yeah.
DTP.
Okay. Also, Mahimarnov and Nikhil. Any ideas from your side? Okay, people, try for 4 minutes more. I'll give a hint at 7:30.
Okay.
Okay, so DPT is equal to DPW is equal to AWI.
Whoa. Slow down.
And is AWI equal to
DPT.
AZI? DPT.
DPT is 90.
No, DTP. Sorry, DTP.
Huh?
DTP is equal to DWP is equal to DWA.
DW. Where is W? Where's W? Okay, DWP. Fine.
Okay, wait, doesn't mean we're done?
No,
Like,
that how?
what? Oh, no.
Correct.
DPT is equal to DWP is equal to
Uh,
IWA. And what else was I gonna say? Sheesh, I
wait,
forgot.
why is DWP equal to IWA?
Because
Oh,
those are
no.
literally straight lines.
No,
No,
like DW.
No.
I is not on
NAWA.
DW, right?
NAWA. Sorry, NAWA.
Okay, not I. Yeah, sorry. Any. Yeah, sorry.
NAWA.
And ADW, do we have anything? No.
Okay, what is NAWA, by the way? Like, it'll be okay.
DWMA is okay. Okay. So angle DWMA is 90 and DWT is also 90.
Yeah.
But we don't know anything about DWA. But AWMA is equal to ANAMA. 180 minus that. A
Okay.
N A M.
Then we could, and A NA MA is like 90 minus A Z. Okay, M. Okay, that we already know. What's the point of that? Okay, perhaps we could do something.
Wait.
Wait,
A
hold
N A
on. Let
90
me just write
minus
down. What are you
how?
saying? You said,
I said that angle AWMA is equal to 180 minus
yeah, that's fine.
ANAMA.
What do you say before AWMA?
What did I say? Before that?
Okay, also people, I have completely forgotten my angle change proof to this, so I will be presenting a solution with Apollo's. So yeah, go on, like angle change, nothing. It was just a small disclaimer or something.
Firstly, what the hell is a Polonius? I forgot.
Yeah, that
No,
I
no.
will tell.
Wait, so what did you get before AWMA, Ronit?
I got that NWMA is 90, is obvious.
AWMA, you had something before that, I thought.
The AWMA is 180 minus ANAMA.
Yeah, but I thought you had something linking A, W, and Z. I thought so.
ANAMA is ZNAMA.
Oh, Z is just annoying at this point. God, can you focus on other stuff?
And ZNAMA is 180 minus, no, ZNAMA is 90 minus NAZM, which is 180 minus, no, which is 90 minus NAZD.
ZNAMA is 180
Okay,
minus.
got it. Okay, cool. Okay. No, like, listen to me.
Okay.
We have, where was that? Wait, what? ADMA, no, AWMA is 180 minus ANAMA, correct?
Yeah, fine.
And ANAMA is 90 minus AZD.
One second. Wait. ANMA, which is
ANAMA is
so
ANM.
90 plus angle NAZM, okay, or angle AZD. Okay, then
Right, because angle NMZ is 90.
90 plus AZD. So AZD should
Okay.
be
Wait a minute.
AWZ.
Just a second, people. This circle is not the Polonius, and I have forgotten my proof, so I'll also be solving with you. Yay. Yeah.
Okay,
Why are
like,
you
so what we
celebrating
got till
getting a
now,
proof?
what we're trying to do till now is trying to get something for AWD. Okay.
Yes.
So for AWD, we're working with AWMA and NWMA.
But
Okay, yeah,
like
I got it.
the question.
Okay. Listen, Ronit, you're right. So
Huh.
AWD, so AWMA is 90 plus angle AWD. Because and then that does it, right? Because
That over, khatam.
done.
Okay.
Yeah.
But H now, we need H.
Now we need H. So
Wait,
okay.
did Mandar understand?
No, I did not.
Okay. So we know that angle AWD is
Yeah.
equal to 90 AWMA minus 90.
AWMA minus 90. Okay.
So AWD is equal to 90 minus angle ANAMA,
Yeah. Got it.
and ANAMA is equal to
Okay, now
ZAD.
what about double H? What do you about H?
Okay,
Okay.
yeah. H. Wait. H, I was thinking something like.
H is
Probably like.
involved with I think. I is the only stuff.
Yeah. H is the only thing that's involved with I. And like, observe that the.
How is H involved with I?
Because H.
BHIC.
Yeah. What?
BHIC.
Not only, yeah, BHIC and XI and XH are tangents to BIC.
Sorry, yeah, that's right.
That's
What?
also another thing.
Wait, is IJH collinear?
IJ. Okay, I'm not sure.
Probably not.
Likely not, but they could be. They are. Damn. Bro,
Wait, look.
what? Wait,
What?
are. Damn, they are.
Oh,
Crazy. crazy
Okay,
stuff.
yeah. XBJC is harmonic. And this
Why is XBJC? Wait. Why is this
Prove it.
trope coming? I hate.
XJBC is harmonic, and XI and XH are tangents to the circle.
Wait a minute.
delete.
So it must be the intersection by that tangent
Oh,
projective.
right.
Got it.
True. Okay, wait a minute. This is like my computer is just going
Okay, so we
bad.
could like I'm pretty sure we could create like a problem out of this.
Yeah, we could likely, and then
We could
like
make 1,000 problems out of this. What do you mean?
like we can't make 1,000 problems because this is like very well explored. Wait, and do these concur? They do not. Okay.
No.
Like we can't make 1,000 problems because this is very well explored. So if you're like see, any of these problems can be given an RMO or NMO, and that won't be explored there. But like at higher levels, you can't give these problems because like people are educated. People are educated.
Wait, so angle
So now we
ZHI.
just angle chase stuff like no other hook in life.
Yeah, ideally we angle chase stuff.
But how?
I don't know.
ZI square is equal to ZB times ZC, but that doesn't give anything about ZH.
Wait, I want to introduce the midpoint of ZD for some reason. Midpoint ZD.
Why
Okay, it's not
ZD
good.
midpoint? Okay.
You
I
mean
was
ZI,
thinking
right?
Not ZI. I was
What is
thinking
ZI midpoint, by the way?
ZI midpoint.
I think the midpoint of ZI might lie on the circle TS.
Okay. Interesting.
Can you just draw the center? Oh no.
Good hopes. But that was a good repel.
That's rough. Anyways, let's see. How would we go about doing this? So like the only thing that's good in
Okay.
any
If we could look at like ZHB, is ZHB 90? No, it's not.
ZA.
No.
No, like
No.
ZBH.
No, it's
No.
not. It can't be 90.
Okay.
Okay. HBC is equal
Why
to
does it look like
HIC.
Wait, is H the altitude here?
No, we just randomly named it H.
No, it could potentially be the altitude. It's not. Sad. Anyways,
Oh, maybe it's the altitude. Wait, can you just draw FH?
FH. Where is F? F, yeah. And H. This line. Yeah. F H.
That's 90.
Damn. Why should it be 90?
I don't know, but it looks like it.
Hard to wait. Let me like move about A and okay, we should not do this. Instead, we should draw the perpendicular onto this and then check if that okay, it's not 90.
It's not.
Oh.
Yeah. That's sad.
We're side tracking. What is this?
Yes, we are not to sidetrack. Okay, we know that this is tangent, so I should probably line dot this thing, I guess. And
Wait,
this
what's tangent?
XH. XH change into BAC.
Oh, okay.
Yes. Now
So,
let's see people.
What about
IAW? We probably want IAW. Is like IZA calculatable? That's the question. Is IZA calculatable?
No, because okay, no. I thought like incent accenter, but I realized it's something else other than the accent. Hell.
It's this point. I
Okay,
don't
can
know
you draw
if it's-
AIB circle just for satisfaction?
Okay. That would just make the diagram much more
We can
clear.
delete it. Sorry.
AIB. Oh, in fact, this guy has gotten so smart. It just makes all the circles and lines dotted now. Like that's
Okay,
good.
now we can remove it. That's nothing useful.
Wait, AIB. Is there anything good here?
no, nothing.
Nah, nothing. Sad.
Okay, so
Wait,
now
ZHI. How can we like get any 90?
We probably can't.
okay, so now we have XHI. Okay, so XHI, is that any useful? XHI X no, we don't have XHZ though.
Wait a minute. So like I want stuff like angle. I don't know. Wait, can I somehow get angle IHW or something of the sort?
Wait.
Or
What is XHI?
XHI. XHI.
Because XH is tangent, it must be some
H
angle inside the circle.
XHI is equal to XIH. So XIH
is 90. XIH is 90.
XIH is 90.
Yes.
XIH.
Oh, sorry. XIH is not 90. It's some weird angle which we don't know.
XIH is ICH. Fine.
Yeah, XIH is
XI is
90.
XHI.
XIH is I no, not I. Okay, wait. Okay, it's angle IMAX. It's IMAX. That is AMAX.
Wait, XHI is XIH. Okay, right.
And
Tangent,
XIH
right.
is this thing, which is like this thing, which I don't know what.
XIH is IMAX. Huh?
Let me just draw the circle. And if it's something good, we would be happy. If it's not something good, we would be
Well,
not
there are way
happy.
It goes
too
through
many
A.
circles.
It goes through
It's
A.
not. I have defined it to go through A.
Oh, okay.
Wait, so X. Wait, you
Nothing
know
particular.
HMAMIX. Okay.
Okay, and also like after this is done, a homework to you people is to invert this diagram about the circle. It's okay. See, it just takes
Okay,
this
okay.
entire thing to the orthocenter config. It's crazy.
What?
Yeah, because the circle goes to the 9-point
In
circle.
center orthocenter duality.
Oh, damn,
Yeah.
the Q point random
Okay, so
mischievous.
MAHI, we can, if we prove MAHI equal to XH, then it's sufficient.
Y, X.
Because angle
True. Yeah.
MAHX is 90 and we want to prove IHZ is 90.
Wait, what do we need to prove? What do we want to prove?
MAHI is equal to XHZ. This could be something like isogonality now.
Bro, if you introduce that angle, okay, yeah.
No, it could totally be isogonality now. Like
Are they similar?
they need
Is
not be, they just
IMMA
make it
similar
as
to TXH, ZXH, sorry.
Okay, guys. MAHI is equal to MAHI is equal to MAIH, which is equal to MBH, which is equal to MCH.
Why is it MBH? Okay, it
Like-
is MBH. Okay, yeah, true. It's MBH.
Inscribed angle theorem.
Yeah.
Wait, MAIH is equal to MBH.
No, is it MBH?
No, wait,
It's
MBH.
not.
MABH.
MABH. No,
No
wait,
way,
why? What?
MAIH is equal to MABH. Huh?
No.
No way, they're different circles.
Yeah,
Oh shit. Okay, right.
yeah. Wait. So wait, do we know like AHW? So like AHW can be written as this and this, which with reflection about I don't
W.
wait,
By
I
the way,
want this.
ZTH should
Wait,
be
can
similar
I
to
somehow
IMMA.
isogonality? See, there are a bunch of lines we should be able to show isogonality. We just need to find out how.
Okay, I think
Thus,
ZTH is similar to IMMA.
ZTH similar to I M
MM.
MA M I M
MA.
MA. That's a wild guess. Why so?
Because it suffices to prove that MMAI is equal to XHZ. Sorry, XHZ.
Let's just like test out angles now. Why are we? Okay, so we are doing
No,
GeoGebra.
not XTH, ZXH. Sorry, my bad.
ZXH.
Control Z, why? Control Z. I think it should save me.
Oh god, I can't stop laughing.
It's
God.
it's ZXH, by the way, sir.
I would have sued Byju's over this.
ZXH and try IMMA. Probably not. Looking like way too obtuse.
I was much ready to just sue Byju.
Wait, why is ready to sue Byju's?
The whole of OMC will support you.
So like GeoGebra is owned by Byju.
Actually,
Yeah.
bro.
Serious.
Yes, I'm not joking. It's actually owned by White.
Did
Okay,
they
So
like
like,
buy it?
wait.
yeah, they bought it
AH,
or something.
XI, and GS look concurrent.
H A
XI, and GS.
HAXI and
GS.
they do look concurrent. Wait here.
Wait,
Are they concurrent?
I can't figure out.
I can't either.
No.
They aren't concurrent.
No. Wait, XJ.
Okay, like just zoom in now. They don't like no three lines are concurrent.
And nothing looks concurrent.
Yeah, exactly.
Wait, no, it looks concurrent with that intersection of circles, but yeah.
No, it isn't. It isn't.
Where?
SPH circle, SPD circle and
It's not. I have tested that.
SPD circle and
Wait,
DEF
people, we are
circle.
off tracking. We need to prove this, else we can't
Shit.
close the lecture and like people might shout at me for like 3 hours lecture. Okay, they won't shout at me, obviously. But yeah, we should be able to prove this, people. We should be able to prove
T is
this.
the midpoint of ZD, is it?
What is BHZ? Can we get BHZ somehow?
Is T the midpoint of ZD?
What?
How can we get BHZ?
No, I'm saying is T the midpoint of ZD.
No.
T the midpoint of no, it's not.
Oh, you tested it, right? Yeah.
Yeah, it is.
How is this BHZ? Because we know BHI is like
I don't know.
angle C over 2.
What?
We know BHI is angle C over 2.
Yeah.
So like if we can show that angle BHZ is 90 minus C over 2.
Wait, isn't BHI more like okay? It is C over 2. True.
Actually, we need to look the other way around. Is there anything good with Z?
That is the point. Now Z and H are just so disconnected of points.
Okay, how do we define Z again? NA is, you know?
Then we have to angle change using A by 2, B by 2. That's our only hope now.
Yeah, true.
A, NA, B is C.
Okay, ZAB is?
So NA, B, Z.
Do we know ZI, ZAI, AZI? Do we know that?
Okay, AZI, we can find it, can we?
Likely, I think we should be able to, right?
Just
Like that just looks like a good angle. See,
Hey,
if nothing happens, we'll just have to bash this. And I don't want
I was thinking the same thing. Why didn't Nishan think of this before?
No, I mean, no.
But like, what bash will you do here? There are just so many circles. Anything is
The
just
synthetic looks like a bash now.
true, exactly. Okay, wait, does this pass through this?
Baddie.
Is it your device or you? Because I feel it's the body right now that's running out of charge.
It's I'm running quite
And
away.
Nikhil's is running out of charge.
Okay, fine.
I am also running out of charge, both my device and my body.
We need to find something fast.
Okay, we have learned that we do not do Control Z because it turns out.
Why don't we keep this as homework?
We could keep it as homework, honestly.
Yeah.
But I want to prove it now. Like, let's just do this. It should not be hard.
It is looking hard.
Yeah, it is looking hard. Wait, we could like give something like this in Lavao image. Or possibly we can make this problem. Like somewhat here.
Like you define W obscurely, like with some.
Yeah, exactly. We define W very badly. We define H very badly, and then
Okay, you define W as like and okay, no, something else.
Then ask them prove that the 6 points are collinear, and they're like, damn, we're dead. That would be so fun.
Okay, he's saying it's
okay, just maybe it's not Apollonian. I was also thinking that, but Apollonian actually goes to like the angle bisector, and this is the touch point. It's not the Apollonian.
Is Z in Eureka?
Okay, wait, just a minute, people, just a minute. Sanity check. Mahimarnub, are you like a senior in Mawardi?
Huh?
He could be. We don't know, right? He could be.
Wait, what did you say? I didn't hear it.
Is he? Like, are you a senior in Mawardi? Like, are you an in Mawardi?
No, no.
Then it's fine. Okay, then we can make it a problem. Yeah. So yeah, we need to somehow prove this. I don't know how to prove this. This sucks.
Okay, IWMA is 90. No, it's not. NAWMA is 90. Bro, I need to write down all the angles and see the stuff. Hey, start deleting circles, I swear.
No.
Harry,
We
this
need
looks so good. Why do you want to delete it? It looks
No, I
so
can't see anything. Like,
Try to
get
see.
better
Try to
eyes.
look between the lines.
Like just get better eyes. Like
no. Like,
Like
I'll cut it out
Nishant in
and
the
put-
middle was like, let me get my glasses because there's too many circles.
Bro.
wait, this is
Okay,
90.
ID is perpendicular to ZD, fine. IH, what's IH doing there? God help us.
This is just like utter randomness. Is this circle does it even exist is the bigger question. Wait, we are not wasting our time, right? Okay, we are not wasting our time. It exists.
It exists, fine. Good.
Easy.
At least,
How do
at
we do
least.
Is there a good definition for age somehow? What if we invert in some weird circle? Bro, that's all I can think of
Okay,
right
root
now.
BC inversion.
Not
No,
root
wait.
BC, BIC. What if we invert BIC? Because H remains where H is.
And
Okay, then
same
we have
is what
some hope. We
happens
got
with
some hope
I.
there.
What?
We have some hope.
Same is with I also.
Yeah, and the circle XIHMA becomes the line IH.
Huh.
Can't I find any orthogonal circles though?
Okay, so
That's
AID goes to
Where
okay.
does Z go to? Where does Z go to?
See,
X.
NA goes to MA, A goes to that guy, Z must go to some circle guy, and then what is circle guy? Okay, wait, we know that we know that Z goes to the median point here. We know that.
Huh.
Wait, by
Like
how?
just trust me on this. I know how to do this. This is like some root BC stuff or something. I don't remember that either, but this happens. Okay, just like take my word on it or something.
Fine.
Okay, it's like error. It's showing that like you're like confirming you're speaking language. Bro, I am speaking language. What is this recording? It's saying that I'm not speaking language.
So MAG, so Z goes to G.
Yeah, Z goes to G. Wait, what would we want this circle to be? Where does H go to? H remains H. Okay. A goes to
D goes to like S.
We want to show that angle
Wait, D goes to S, right?
HGI is 90.
yeah, D goes to S. Indeed.
What?
What?
We want to show angle ZHI is 90.
ZHI. We do want to show that, but we are inverting about BIC because we can't do anything.
So what does that, what angles stay preserved? So what angle do we want now?
Does it stay present? No, they don't stay present.
There's no, it's not connected to the center. Like,
Yeah, only like the central angle.
No,
Okay,
like C.
anyways, A we know goes to the intersection point. D goes to S.
A goes to M. No.
I
D goes
remains
to
where
S.
it is.
SI is defined. S and I we have. Okay, H,
And then the
SIH. What is
intersection.
SIH?
Okay, wait, this might actually be good.
SIGH?
Wait, people. This might actually be good. So all we need to do to prove this circle is
SIGH.
S I
GH, yeah.
H.
We need to prove this exists.
Yeah, we need to prove that this circle exists. This is much more doable, I think.
Looks
Okay,
much
this
more
probably
doable.
lies on the radical axis of 2 points. So SG is on the same circle.
In
IH
fact,
And IH is on the radical axis of.
Oh yeah, we're done.
Wait, how? I don't get it.
Explain.
No,
Look
don't
at
say
it.
how. Don't say how. Let me try.
What the heck?
Don't say
Bro,
how.
wait a second. This should not be hard or something, I believe. This into this, that into that. Oh yeah, got it.
Wait,
This
PowerPoint.
is crazy.
We don't need PowerPoint also.
Wait, then what did you do?
Just radical axis. Look
Okay, let me think. Radical
Wait,
axis IH,
I
right?
popped it. I did power of point. I did
I
power
did
of point.
I did
to-
radical axis. What the
I
heck?
did power of point
We
to
all
J.
have wait, this could actually go into Lamar Revenge. I
Yeah,
feel.
this could go into Lamar Revenge. This is a great problem. We should totally put it up on Lamar Revenge.
Wait. You
Like some
guys use
variant of this,
radical axis
obviously. We can't put
IH,
it.
right? Radical axis IH.
Yeah.
Okay.
Wait, how do you do it with radical axis?
I'll explain.
Wait a minute. Don't explain right
Which
now.
radical axis? Which radical axis?
No, if I tell that you're done, right?
So that's the problem now. Which radical axis?
Okay, IH is the radical axis with I don't know, ZIGH. Okay,
come
got
on.
it.
Yes.
Got it.
Mandar?
I didn't get it. Wait, what?
Okay, Nishant,
I
explain.
yeah,
Okay.
just explain.
Okay.
I pop through J and it works.
Okay, listen. Okay, so now I and H lie on BIC circle.
I and H lie on BIC circle. True.
And then S and G lie on ABC circle.
S and G lie on ABC circle. True.
So their radical axis is just BC.
True.
And lies on BC. And J is the intersection of those two. SG
Okay.
and
Okay,
IH.
that was my proof as well. Like I did like JI into JH is JB into JC is JS into
Okay,
JB.
that's the same thing.
Yeah,
Actually,
that's-
this feels like really good.
All three got the same thing. Let's go.
Like we just need to prove Z goes to J. That's the only thing left. Z goes to
why
J.
Z goes to G. Do you want to? Okay, that's okay.
Okay, no, I
can
think we can do that by projectivity. So
wait, just a second. Let me just draw some circles and show that, like, mark this circle as dotted as well. And do you want to switch to a different GeoGebra for that? Because I'm pretty sure that's like
No,
very
I have
much.
to
I
mark
want
the
to try
angle
it on my
bisector,
own.
the intersection of the
I want
angle
to try it on
bisector
my
and
own.
BC.
Yeah, like we should just like wait for like 5. Okay, do you want to try it on your own? So like, do you want me to end the class or something now?
No,
Yeah,
wait,
you
yeah.
can end it.
He like one guy is like you can end it, other guy is like no, don't end it. Also people that group solve you were talking about like today or what?
Right now.
Bro, not right now. I have to have my dinner.
Okay, right, sure. I forget about dinner. Okay, then when?
Wait, hold on. Wait, I think I'm almost done. Just can you give me a second?
When do you people sleep?
Anytime
Let's
you
not talk
tell.
about me, bro.
What?
Anytime
Don't
you
talk
tell.
about me.
Anytime you?
Tell.
Yeah, then like same. I am also.
Okay, I'm not sure, but can you mark the intersection of the angle bisector of A and BC?
Okay, wait. You want to show that that maps to G, right?
No, just can you mark it? You just mark the angle and intersection of angle bisector of A and BC. Yeah, it lies
Wait.
on that circle. Intersection of that circle.
Intersection of angle bisector and
BC. That's that.
BC. Yeah, it has to lie on the circle.
Just name the point. Could you? I want to just think.
Let's see. It's N.
Okay, so now I think N is the orthocenter of NAMAZ.
NAMAZ. That is indeed true.
Wait, so what?
Yeah, we are done. Great.
Yeah, we're done.
Yeah, great.
Wait, what is the
No, this is
orthocenter of
perfect for Lamar Revenge.
Exactly, bro. Like not this, because this is, I believe, easy. This is not.
No, you can just like you add up all these stuff, and then you just
Yeah. We could like do some obscurity. In fact, I was thinking there is this beautiful property. I think that you introduce all the three Sharkies, and then you like get some very weird coaxiality with the three Sharkies and something. It's like crazy stuff. But yeah, we should
we could
totally
propose
explore
like
this.
we've got like
Yeah, we can totally
Wait,
propose.
who all are going to be giving the exam, the Lamar Revenge?
Seniors, the people who have like cleared in more.
All the seniors.
All seniors give it, including past IMO medalists. So yeah, that's fun.
How past?
What?
How past?
visuals like.
Oh no, like the ones who are eligible for IMOTC this year, only those. Not all. Bro, like Rajesh Srivastava is not coming to give Lamar. Okay.
Man, I wish that happened.
Yeah, that would have been crazy. Okay, wait.
Okay.
We should not wait just a minute. So we are done, right? So we should not include gap in this.
Yeah, just N is the orthocent. Damn, we got so many stuff is the orthocent of others.
Yeah, people. So that was our class. Thank you for like attending for 3 hours. Like Nishant, Ronatan. Okay, wait, I don't want to butcher his name. Mohimarnab Kumar Roy. Thank you for attending. Wait, I didn't
Of
butcher his
course.
name, right? Okay, wait, let me close